There we go. New file. Cool. All right, here we go. So much for the tables. So much for the saw jig. I guess that's not happening. So I'm gonna clean up a little bit, and then we'll do some ghost hunting. Let's hunt for some ghosts. All the other ghost hunting tools are too expensive. It's like $100 like anomaly radio. You know, basically they're all just trying to scam you. So ghost guns are the new thing in our schools. Don't say that. Don't say that. Ghost guns, they're talking about like 3D printed guns and guns that don't have serial numbers on them. They're not a big thing. There are people who are making plans for 3D printed guns though. They're pretty clever. I think it's a roller blowback design. Put the clamp away. The wrench will eventually have to make its way back out into the hallway. Can we talk about something else, you freaking assholes? Mentioned ghosts, and now suddenly we're talking about like guns and school shootings and shit. Yeah, no. Stop. Bringing down the mood. Just gotta bring everybody down with you, huh? Oh, the sun's out a little bit. My ghost window keeps opening and closing. Gotta burn the subs view. I'll train it on the ghost window. The shop is haunted, Chad. Shop is haunted. That window is gonna open and close at random. Oh my God. Well, now it doesn't do it because we're watching it, because that's the ghosts. That's what the ghosts do. They stop once you start watching them. Yep, and there it is. They got stage fright. Ghosts got stage fright. Oh my God, it's moving on its own. It's haunted. Call Joe Phasmophobia. Get him in here. Put the wrench back on there. Put this back over here. And now I just have a bunch of wood chips on my table. Great. Wonderful. Oh my God. Well, that bar that's sticking out right there, that's what I use to prop the window open. That's all that is. Hinge is fine. Well, you guys are just really great to hang out with. I just really love hanging out with you guys, telling me to fix my window and getting stuck on political topics all the time. I just love spending my time with you. I'm gonna ban my whole fucking chat. You're all fucking banned, all of you. None of you can get your heads into a positive space. You can't look at something without making a little snide comment about it. Gets to me. It really gets to me, actually. You guys check your attitude at the door, all right? We're having fun today. It's Friday. It's a holiday, sort of, for some people. It's a snowstorm. We're all locked inside. We got to tolerate each other. So that's what we're going to do. We're going to make fun of ghost hunters because they're dumb. And I'm going to stop responding to the people who are making negative comments. All right. I got my tape. I got my soda. I got my rusty screws. We're ready to go. Let's do this. These go in the garbage. Let's go in the garbage. This is very much go in the garbage. There's still, how are there still wood chips? They must have been on the tape. Soda cured. I got wood dust everywhere now. No, the negative politics thing is Raba's energy. What are you talking about? That guy cannot stop talking about politics, and he does it just to trigger you guys. I hope you know that. You guys should know that by now. You're not that dumb. That he talks about that stuff to get his chat boiling. It's diet soda. It's not going to be sticky. I got these strips recently that you can actually use in order to test whether or not a soda is diet, which is a huge improvement over what I did before. What I did before was use a blood glucose test strip, which is like 60 cents a piece. Okay, I'm still getting gritty stuff. Ugh. I gotta do this every time. I need like a wash down function for my desk. you can buy these cheap little bottles of strips that are kind of the same thing as like a what is it, a ketone strip. It's like a ketone strip for diabetics, where it'll show you sugars as well as ketones. However, you know, they don't sell them. They don't sell the dual strips from what I can see anymore. So you can buy a strip that's just used to evaluate soda and whether or not it has carbohydrates in it. That's a thing, because when you get fast food, you don't know if they hooked the right hose to the right outlet. And so you can get a scenario where they swear up and down that you're getting diet soda, but your glucose level goes to 500 because you've just had an equivalent of the burger that you ordered in carbohydrates from your soda. So what that thing does is it allows you to test whether or not the soda has sugar in it with a certain like bubble of certainty, because there might be like latent carbohydrates, or it might be partially carby, or so they have sort of it's like a range. It's like a fuzzy range, but that was a big quality of life improvement. Okay. Ghost hunters. Found this thing online. Was watching a video, and the host of the video, she mentioned this tool for ghost hunting. She actually mentioned a couple different tools for ghost hunting, but the other tools for ghost hunting were like more than $100 each. So one of them was like $200. Like, this is not my budget. So this one was like $20, and it seemed to be the most rudimentary of the devices. Basically, this is the sector of ghost hunting, what involves interference and noise. Interference and noise is everywhere. You're going to get it no matter what. You run your microwave and your phone suddenly can't connect to Wi-Fi, right? That's a thing. There's all kinds of stuff out there just floating around in free space. And so that space is part of where ghost hunters have retreated to. It's where the goalposts keep moving. And so we're in the space of randomness. We're in a space of random statistical weirdness and signals that might be floating around anyway. Like, you know, your cell phone is periodically talking to the tower in order to get a certain amount of information about what's going on. That's where we come in. That's where this thing comes in. That's where ghost hunters come in. Suddenly, you're reading a signal and you notice that there is a particularly large amount of noise, and you go, oh, something is manipulating the ether, and that's definitely going to be a ghost. And so you have a confidence man or woman or person, a confidence thing that is basically going to tell somebody that they know exactly what's going on, wherein we know that it might just be sunspots. This thing also rattles when you shake it, which is great. That's a real sign of quality from these things. These charlatans, these hucksters, these fucking assholes have basically taken ghost hunting to the next level, where they're starting to, like, you know, some people got caught faking things and you know, noises in old houses. Oh, look, there was a pop noise. Ooh, what was that? It was a ghost. It was definitely the ghost of this axe murder. No, that was just the wood expanding in the house because it's 90 years old. So anyway, I want to take a look at how this thing works and figure out what it does. There are legitimate uses for something like a milligauss sensor. You know, this would take a look at the device you made and see if there's a lot of, you know, if we got a lot of ambient noise in the area, or maybe if your noise is, or your device is emitting a lot of noise. I know that there are radar detectors that the police use, and I think there are also radar detectors. I think it goes 3 levels down. Because what happens in these RF devices, like for instance, a device that is sensing whether or not a radio frequency signal is coming in, it has to calibrate itself on something. So it will have an internal oscillator that it uses in order to create something akin to like a derivation of that radio signal that it has to look for. So what it does is it has that internal oscillator. That internal oscillator is going to emit stuff. This is why you have metal cans around radio frequency components. But the cheaper radar detectors will emit something when they power up. And so the police have a device in their squad car that detects that. And people have been recorded filming into a police car that's parked. When they have their buddy turn on the radar detector, they see the light turn on. And so the thought, I believe, and I think it does actually go another level. This is getting into way too expensive car stuff. Just drive the speed limit if you're this worried. Where you have the police turning on their detector, and that has an internal oscillator in it that could be detected by a radar detector. I don't know how many levels down we are now, but it's this whole arms race that people are doing. That's interesting. That radar detector is akin to this thing. This thing is basically a device that you would use in order to measure like the ambient noise in an area or the ambient noise coming from a device that you've made. Now, I've got a Bluetooth device sitting right here. If we get into the interval of what is it, 5 minutes that this thing communicates in, we'll see this thing spike. This thing was at 2 dots before. So, I mean, we could just wait right here and just see when this thing does its whole thing. I didn't know they could detect the car had a detector. They can only detect the detector when you turn it on, because when you turn it on, that's when it calibrates. It's a whole thing. I'm not seeing any spikes. We should probably be seeing spikes at this point. But yeah, this thing is one of those things. This is one of those things that ghost hunters love using. You get near an electrical socket and suddenly you've got 120 or 60, sorry, 120. You got 60 hertz of power wibbling about. That's bound to do something to the ambient signals in the area. My oscilloscope shows a lot of noise on it, and the reason is these lights are LEDs, and they're on a dimmer. And when that thing dims, there's like I think there's something you can do with capacitors on this in order to stifle that noise, but that creates electromagnetic noise. And so you could see it in the oscope. You could see it on this thing when I put it right here. Or is that just me? Oh my God, it's a ghost. I wanted to get one, but it's illegal here. Yeah, the legality varies here from state to state. I know they're illegal in Virginia, so the cops have those devices. We got any ghosts wandering around? What about power line ghosts? Ghosts love power lines. Look, see? Ghosts. We got power line ghosts. I knew it. I knew it. I just knew it. I just knew it. Do we have any fart ghosts? Oddly enough, we do not have fart ghosts going on this thing. Strange. Strange. And it's also strange that nobody's set off one. There it is. Ah, nothing. Now it's going to do a fart avalanche. Yeah, there it goes. There's all the interference. You guys are barely registering. It's sad. It's actually kind of sad to see. You gotta wait. There's a the broadcast delay is what's causing that. But this is a nice, cheap little tool to measure just like noise in the area. I guess it's kind of a piece of garbage, but I think it would be very fun to take apart. So let's do it. Where do we start? I mean, there's just 2 glaringly huge screw holes on the back of this thing, right? So we can figure out exactly what the chips are in it and how they function, unless they've tried to keep it a secret. Some kill the power in the building and try to avoid people. But they're filming it, and I don't know, man. Oh my God, my phone has ghosts. You know, any reasonable amount of RF will get into a building unless you put a freaking Faraday cage around it. And when you do that, I can guarantee you this thing will be completely stable. People don't naturally just make radio frequency noise. Anyway, ghosts are not trying to communicate with you in the fringes of what we can detect. That's not a thing. Here's a screwdriver. No security torques on this, so I don't get to do my cool comedy bit where I just stick a flathead screwdriver into the security torques. Why go to all the trouble of putting an ESP inside when the camcorder you're using is enough to create electrical interference? You know, if you're recording yourself doing this stuff with your cell phone, well, it's a goddamn cell phone. Hope there are some grub screws. I could fill it with grub screws. I bought grub screws. I guess this is how they rely on you. Wow. Heavy duty. Nice. Okay. This one is more advanced than the one that I saw in the video that I watched. This one is a little bit more advanced. They've gone to surface mount technology with this, which is nice. It's nice. I mean, this device does not have a nefarious purpose to it. It's not, I mean, the listing might have put ghost hunting in the description, but what this thing is really supposed to be doing is just looking for electrical noise, right? It's looking for RF noise in the area, and it's just reporting to you on that. It's really, it's not like, you know, red equals ghost. It doesn't say that on the packaging for this thing. Let's see what we're up against, though. We got all kinds of... What? Oh, yeah, that's right. I moved the... I moved the microscope. I was like, what the hell is that? Let's come on down back here. We can see what's what on the bench. All right, we haven't done one of these in a while where I take stuff apart. I'm going to ask you guys once to not read ahead. I understand that you guys are smart and you want to show off how smart you are. It's my show. So you have to let me do this. You have to let me have a show. Okay? Just don't read ahead. Stop. I am discovering this with everybody else, and we're doing this at a pace that might frustrate the people who know about electronics. But I'm not trying to reach those of you that know about electronics. I'm trying to get the people who watch Rabaz to somehow keep up with me. That is a very difficult task. And in fact, the comment that I get most often on this stream is, Bother, I love what you're doing. I love how you say it. I have no fucking idea what you're saying. And that's fair. I get that a lot. I don't necessarily like getting that all the time. I don't like that being my only feedback. So we need to slow it up. We're doing something nice and easy today. We are making pot shots at some... I'm unplugging the fart box right now. We're taking pot shots at somebody else's design while making fun of ghost hunters at the same time. So let us do that instead of trying to tell me all the facets of the design on the precipice of when I get to the good stuff. Because you guys want to relay the good stuff back to me immediately. I need to get to the good stuff, and I need to build a narrative around it. Okay? That's it. That is my disclaimer at the beginning of doing this, because we haven't done this in a little while, so I got to lay down all of that ahead of time. Because I get smart people in chat, and they're great people, but I need you to rein it in and not get ahead. So, what is this device called? I actually, you know what? I'm gonna have to go ahead and look that up real quick. Let's open up. Wow, I've got a lot of the laser diode research section was tough. Yeah, if you wanna be smart, check out the Discord. You don't have to be smart though. Call the police. There's been a dog napping. My dog is at my parents' house. I'm so sad. My dog is at my parents' house. Well, actually, no, it's not at my parents' house anymore. She is now at my brother's house in Maryland. Okay, hold on. I've just got to go all the way up here. I'm looking at what this thing is called. Huh? We got one follow this minute, so don't trust the Twitch numbers to be any source of information. They're a very much approximated number. When are my gloves getting here? Tomorrow? Tomorrow to very much further than tomorrow. Okay, so this thing is a 5 LED EMF meter, magnetic field detector, ghost hunting paranormal equipment detector, portable EMF reader tester for home EMF inspection, office and outdoor ghost counter. Ghost counter, huh? Like I said, the listing is where all the deception is. I don't know what this product originally is called or who or where or what. That's up in the air. But the lister, the person who's listing this thing, knows that this is used for ghost hunting and probably jacked the price up a little bit for it. I mean, this is like a couple dollars in electronics when you get the economy of scale going on it. Wow, the battery terminals they don't even have strain relief on them. Oh, ooh, ew, ooh. Okay, I'm already from a distance, a little bit further than you guys are looking at it. I am seeing quite a few weird things about the design of this. But as with any reverse engineering effort, what we need to do is go in here and look at the chips, and we look at what chip is being used or chips are being used for the systems, and we can put together how this thing works exactly from the data sheets of these chips, which is why I got a little cross with people listing electronics components ahead of time. I need to narratively get to that point because I'm teaching you guys. I'm teaching you guys how to reverse engineer stuff at the same time. What up, Wazoo? So anyway, this ghost hunting device relies on one chip. I can see from here, without even getting into the microscope, that there is one singular chip on this board and a whole bunch of accessory electronics. It's almost got it onto one layer, huh? 8 bits, one's weird, huh? The feed, oh, the glowing veins. Yeah, isn't that great? I have this thing where my body creates too much iron, and so periodically they have to basically make me give blood. I don't know if I'm allowed to give blood with the medications I'm on and the diabetes and stuff like that, so they have to do it at like a cancer center, which is, it's ridiculous. I'm sitting there next to people who are getting chemo, but they have to like shove a bolt-sized needle into the side of my arm and get a bunch of blood out of me, and that reduces the amount of iron in my blood. I wish I could take this with me because this is a, stop it, reading ahead. This is a passive infrared sensor. It is a Lepton 3.1, or no, 3.5, really? That is hooked up to a webcam module. The only way I was able to get it to get enough frame rate and get it onto OBS nicely was to use a webcam module. And that was pretty expensive, but the IR sensor itself can be very pricey. Prices are going down for it though, economy of scale. So what it's showing is it's showing the radiative heat from my skin. My skin happens to be slightly warmer where my veins are. So you can see the vein structure. There's actually a better way to detect veins under skin, and that's using near infrared. So there's a device that actually has a camera in it that can see near infrared, and it shines near infrared onto your skin. Well, some frequencies of near infrared pass through skin and bounce off of blood. And so what they do is they project green onto all the places that they're not getting a reflection from. And so what that device does is it projects an image, and it'll have like a perfect contrast of exactly where the veins are. Really cool device. I want to make one. I'm gonna make one of those someday. Anyway, for now, we've got really, really crappy ghost hunting equipment in front of us here. So yeah, that's just thermals. If you see any ghosts on thermals, let me know, because that'll be important data. But for now, the ghosts are just simply opening and closing the window to the shop. Ooh, 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 ooh. Well, I guess not. All right, anyway, back to the microscope. This is the microscope. This is another thing that people ask about frequently. What this is a Logitech C90 something or other webcam that's been hooked up to a C-mount lens spacer. The C-mount lens spacer moves the Nikon camera lens away far enough that this thing is able to do slight amounts of macro photography, and that slight amount means that we can actually get down to the size where we're viewing all of the silicon structures on a chip. I have to put a bunch of spacers in to make that happen, but the advantage to this is that, first of all, I get Logitech webcam quality. Second of all, I get this much standoff distance, which allows me to do a lot of work with soldering. When I use it, I view it through the same screen that you guys are. Basically, I'm looking up and keeping my back straight, which is why I don't have back problems as an electrical engineer. You gotta be careful about this stuff, you know? You wanna preserve your comfort, which will then preserve your, don't sit like a shrimp when you're in your desk chair. Everybody sit up. I don't want you guys having back problems. All right, anyway, so the electronics on this thing, man, they certainly spaced everything out on this sensor. I would have expected a little bit better discipline or better runs of these traces, considering that this thing is an RF detector. But I don't think a lot of effort went into this. Like, that is frightening right there. That battery minus. Why are there not ground planes on this thing anywhere? No ground planes. Oh Lord, oh Lord. Now, this is not bad. You're just not supposed to do that. It's generally just like aesthetic reasons, but we are working in the radio frequency spectrum on this, supposedly. So why, the thought was that RF could be leaking out of those corners, or that the etching process would not favor those corners very well. And you can see that the corners of the traces get kind of a little weird. I mean, I guess that stands to reason. So you're supposed to like do 45-degree. I need a pointing device. I remember now that after working on your car for like several weekends, it's probably not a good idea. You need like a pointing device, because people just don't want to. People don't want to see this. They don't want to see this stuff. All this crap that's under your fingernails. Yeah, all the car detritus that's under there. All right. Anyway, pointing device. I use this little hook to point at stuff. This is my new arm. So yeah, 45-degree angles, and that's just to keep people from having a vein pop out in their forehead when they look at your design. That's it. That's the only purpose of it. We've gone through the ringer on this. The only reason that you would really want to be careful about how your traces are run is if you are in the high, like you're making a circuit board and it's got all kinds of like high frequency RF stuff going on, or high signal speed stuff going on. Maybe then you want to you want to use slightly better trace discipline on it. But generally, this is fine on this level of electronics. Then again, this is an RF detector. So why do we not see ground planes here? Why do we not see 45-degree angles? This thing is a novelty toy. I've all of my confidence in this design left even before I saw the cold welded solder joints on the power input. There's no strain relief on this at all, by the way. So like the third or fourth time you change batteries, one of these is gonna travel. Decoupling capacitors, a couple transistor circuits going on here. I would have expected to see a little bit more repetition out of this thing, considering that it's running 6 LEDs. So I've got 6 LEDs, and they are all connected to the same chip, and the chip is an LM324. LM being a very common part number designation. LM324, and I believe I think that is a differential amplifier. So let's look it up. So if we're dealing with a circuit that's smarter than this, there are the ground planes. If we were dealing with a circuit that was smarter than this, we might have multiple chips to look up in order to figure out what all the functions are, or we might have, different like digital electronics and stuff to look up. But really, reverse engineering starts with the chips. So let's take a look and let's see what the data sheet looks like to that. Hey, Mad Cat, Merry Christmas back to you. Okay, let's get a browser window. 210. Hold on. First, I gotta see what's going on with friggin' diabetes. I gotta figure out what's going on with my diabetes. Hold on 1 second. My phone. I think I activated something with Google, and it said, try asking your phone to play relaxing music. It's like, are you sensing that I've been yelling for like 45 minutes? Do you want to give me more insulin? 0.3. No, I'm taking over. Give me 6 units of insulin stat. So actually, turn this thing on. Connecting. I don't know where the Bluetooth antenna is on this thing. Where are we focused? Where's our focal point here? Wind's howling. Come on. If this thing doesn't detect Bluetooth, I don't know what the purpose of this device is. Is it just ghosts? Is it just ghosts? Or are they actually like... I need to keep the screen alive. Come on, man. Here it goes. So the Bluetooth handshake has occurred. We didn't see any additional RF noise. We're gonna really have to, we might have to measure some traces to figure out what the frequency is on this thing. How goes the upgrade to the continuous insulin? It's not continuous insulin. Well, it kind of is, I guess. That's not really the way you refer to it, though. But yeah, I had to go through a whole bunch of training for that, and that took like months, right? Because it slowly brings you through the training until you have your closed loop system. So I've closed the loop. I just have to, this is called looping, I guess. I've closed the loop, but now I have to get into some of the additional features that do things like detect when you've eaten a meal and things like that. But for right now, it's actually been doing a great job. My A1C is down, which is sort of a cumulative, it's like a biological test of the average glucose level that you've had for 3 months. A1C's gone down, weight's gone down, just a lot of good improvements. Okay, I've forgotten the number that I was supposed to remember in order to look up this part, so I need to go back to here. LM324. This is a lot different from the one that I saw in that video. Maybe the LM324 is cheaper than the low power quad op amp. Yep, quad op amp. So this thing is comparing two voltages in order to figure out what's going on. We have a structure that has 4 op amps in it, and they are placed around the ground and voltage plus pins in the center. That's sort of the difference between this and like a 7400 series logic. A 7400 series is like a 5-volt logic series of chips. Whole bunch of chips involved with that. They would have something like pin 1 and 8 or pin 7 and I think it's 7 and 14 would be power and ground. But instead, this has 11 and 4 as its ground and voltage. And you can sort of, you know, you can tell a quad op amp when they do stuff like that. You know, it's a fairly common circuit structure. Uh-oh, did my computer power off? No, it's still on. It just turned off the monitors. Okay, good. I've had troubles with my computer resetting. and the windows blowing open randomly. Whoa, the windows with the ghosts of Christmas present. Okay, the window's not blowing open, but it was, I swear, and it was ghosts. It was definitely ghosts. I unplugged the fart machine, by the way. I unplugged it. Chat was being belligerent about it. So, LM324. LM324. Quad op amp. That makes this a lot more difficult for us to reverse engineer. I might have to employ an MS Paint drawing in order to figure out how precisely this thing is determining whether or not the LEDs should be active. Now, right now, what I'm doing is I'm inducing capacitive noise in it by touching it with my finger. This is known as circuit bending, actually. Different locations in the circuit board are doing different levels of EMF comparison. So let's figure out how it's... Oh, I can already see how it's doing that comparison. I can already see exactly how this thing is doing that comparison. So what they've done is they have their first comparative voltage is coming in. The second one is just floating. This is just floating. When you let a pin float like this that is high Z, what happens in this pin is that it is subject to random deviations of the voltage level on it. So there's nothing bleeding this away down to ground. There's nothing applying power to it. It floats. And they do this in the Arduino quite a bit. They have pins on the Arduino that you can reference, like the analog input pin. If you reference the analog input pin of the Arduino and there's nothing connected to it, you can get a pseudo-random number out of that. So welcome to EMF, pseudo-randomness. Excuse me, burp right on my stream. I usually mean to mute those. Let's figure out what one of the circuits looks like, and we can probably determine what the rest of them look like as a result of that. So we'll start with, well, I guess we start with the first LED, which is always lit up. This is probably going to be the most sensitive one and have the smallest values on everything, and probably the smallest or most closest to 0 voltage here. Now, I don't know if they're doing anything to offset the 9 volts and create a positive and negative voltage out of it. Maybe that's a place to start. This is our V minus. V minus goes around here to the middle of the switch. Don't know where it goes from there, so we can determine that later. Battery minus goes to a big spider web, which this is just ridiculous. This is just simply ridiculous. I got 2 grounds running away from my ground. Why? What the fuck? Like, competent circuit design? Incompetent circuit design. It's almost like they're trying to foster a weird relationship with noise in this device. That That ground goes to a Zener diode. I guess that's where they're making their internal voltage. Zener diode, if you hook it up in reverse, it will end up, because of the way the silicon is biased in a Zener diode, basically when you have a diode, all right, I don't want to get totally into diode design, but I guess I could just go through the spiel. When you get a piece of two pieces of silicon and you dope one of them so that there's more electrons, and you dope the other one so that there's so few electrons, there are what you would refer to as holes. So you got one with holes, you got one with electrons, and you put them together because of the nature of one being a little bit more negative from the holes and the other one being a little bit more ghosts. Oh my God, the window moved slightly. Because of the relationship with positive and negative in electrons and attracting and repelling one another, when you put two big pieces of silicon together, you get this boundary condition where they meet, which has the opposite effect of everything. That's making a diode. If you then put a very large positive signal on one end or a very large, I don't know, negative signal on the other end, then that region will expand to the point where it conducts. That's sort of what we do in order to take advantage. This is how we tricked rocks into thinking, right? If you put enough voltage on the two ends, there's enough of a bias that the boundary layer expands to the point where it conducts. Once it does that, you can have infinite current go through this thing until it explodes because of the slight resistance. Now, all that stuff that I just explained, you will have to go through an entire 101 level electrical engineering course to learn. They don't tell you the simple stuff until you're at the end. I wish they would lead with the simple stuff, because they lead with the simple stuff. They lead with all the equations and the derivations, and they say this is how they discovered this. And I'm like, I don't give a shit about how they discovered it. Like, how do I need to use it on the test? How do I need to use it in my career? And this is it. It's just put two pieces of silicon together, boundary layer, you made a diode. Put another piece of silicon on the end of that. Now you have a thing in the middle where you can actually activate the current flow with a separate, smaller current flow. And that led to computers, which led to programming. I unplugged the fart machine. I don't need it right now. I'll plug it in later, but you don't get any refunds on those, by the way. There are no refunds. A comparator is a slightly more complicated thing. It's like the embodiment of math in silicon. It's a bunch of transistors that we put together in order to take two pins and say, hey, what is the difference between the voltage on these two pins? And then that third pin will output that. And you can do a lot of complicated stuff with it. We're about to learn what these guys did, these people did with, I use the universal, like the Royal Guys. The Royal Guys. I used to actually play keyboard for those guys. Anyway, I use like guys is like the most nebulous term in the world. I don't know if I'm allowed to anyway, whatever. The people who designed this thing, we get to figure out what they did, how they created sort of a random bias on their comparators, and how that relates to the scientific nature of this $20 device. I'm going to tell you right now that it's completely ridiculous, right? It's like the more random noise that we get on a floating pin, the more LEDs are lit up. And so that's related to basic EMF, and it's something that the Arduino takes advantage of in order to create random numbers. So, all right, so windows keep blowing open. Sounds like you got to fix those window locks because of the high wind gusts. I don't know if you were paying attention, but that's fucking ghosts doing that, man. That is definitely ghosts and not a wind advisory in effect. Okay, so please don't fun fact my stream. All right, so we're looking at this. We found out that there's a quad comparator sitting on this. Now we need to figure out what one of the circuits look like, because I have a strong feeling that we've got a repeating circuit structure here. We've already found a Zener diode, and what I was explaining before I got rudely interrupted by my own tangent is that a Zener diode has a particular, it's doped in a particular way. They baked that silicon in a particular way with a particular amount of substances in it, so that if you bias it in reverse, it's got a slightly different looking current chart. What it does is it basically, the more voltage you put into this thing, the more voltage it bleeds off in order to hold a steady voltage. So if you reverse that diode that's doped in a particular way, it can work as a rudimentary voltage regulator. It'll hold your circuit at a certain voltage. So in basic electronic circuits, you will find these things a lot as a I believe that they are a cop-out in electronics design, because they're inefficient. They're dumping all of that extra current in a way that is not good. We have much better ways to do it. We have ways to switch it on and off, or to do what's called bucking it in order to bring down that voltage level. Even lazier than a Zener diode, though, is just to put diodes in the path of your current, because across a diode you have a voltage drop. That's the diode's internal stuff that needs that voltage in order to function. So on one end of a diode, you'll have your original voltage. On the other, you have a drop of approximately 0.7 volts. So if you're in low current stuff and you need a slightly lower voltage, you can put like 2 diodes in the way, and you could drop it 1.4 volts if you've got a 0.7 volt drop diode. That is a huge cop-out. I hate that. But I guess it functions the way it does. And if you're not blowing up your circuit, that's okay to do. Anyway, we're using a Zener diode, so we're still in my shit tier list of voltage regulator methodologies, but it might be appropriate for such a silly low power, low cost device. Okay, back to the circuit. Those are normal diodes, and they are in series with one another. Damn it. So I guess they are doing that. They're doing everything that I don't like. We were following the ground. We were following the ground trace just to see what some of the design, what they're doing with this thing, right? See, here's a ground plane. This is responsible circuit making. I have this weird feeling that when they take the ground planes away from this part of the circuit, they probably get better performance with their thing. What is this precisely supposed to be measuring? Ghosts. All right, so we're negative down here. I mean, this is supposed to be sensing EMF, so generically, I guess, just whatever's running around in the air, this thing will be picking up. Why does it go to the positive? Oh, because this is the positive part of the Zener diode. I have a feeling that over here, nope, it's not. So we're making a bunch of different voltage levels, huh? It's the horse meme. It is kind of the horse meme. You're kind of right. Is this one just always active? No. Okay, so these are set up in a way to cascade, I guess. This one's connected to ground, and then each subsequent one connects to a circuit. All right, all right. Well, we got 4 comparators and more than 1, 2, 3, 4. Ah, ha 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 ha. Listen, chat. We have 4 comparators right here. 5 lights. 5 lights, 4 comparators. I don't think 1.5 is ever turning off. I hate to break it to you. I don't think 1.5 is ever going to turn off. But let's find out. Let's see what the circuit looks like. They might just be biasing it like a transistor. Just shaking the circuit is enough to make stuff happen. All right, well, yeah, I guess we start with light number 1. This is like the Picard detector. There are 4 lights, 4 functional ones anyway. Hey, I even got red to light up there. Is that 1 ghost or is that 2? All right, anyway, start at the beginning, right? We've got a surface mount transistor, which are some of my favorite components because the symbol for the transistor is a bar with 2 arrows coming out of one, well, an arrow going in or out, and then a pin coming at the other one, and then we get a little what's called the base coming out of the one side, right? I can do this in MS Paint, so let's just MS. We're gonna need a way to take notes anyway. So we go over to this screen, MS Paint. So the symbol for a transistor is this: a line, an arrow, possibly in or out. And there's usually an arrow here or the arrow here. And then we've got a line like this. So with this specific transistor, what happens is if you have this sitting at 0 volts, nothing happens, right? But then if you bias this to positive, a little bit of current goes this way, and a lot of current goes this way. And so what you're able to do is you're able to have something here, like a load, with positive power, and then you've got negative down here. And so you're able to switch that load by putting a slight positive voltage on the transistor, right? It's a great way to trigger a relay. Of course, then you have to have a flyback diode when you do a relay. So that's transistor, right? So the surface mount transistor looks like this. It is a box with 3 legs, right? So it stands to reason that they're set up like, nope, they're not. And I have to look it up. Because I don't quite have it memorized. So the surface mount transistor is set up so that this is the base. This is the collector. And then this is the emitter. Totally and completely intuitive. It's great. I think the only reason that that really makes sense is because sometimes you bias your transistor when you're using it as a switch, and you put a resistor there to ground. So you would have a resistor to ground, and then you would also have your emitter go to ground. And so that means that you just put a resistor right here. You just put a chip resistor right across those leads, and that makes it nice and easy. But boy, who came up with this fucking convention? I wanna like unbuy them lunch. I wanna not buy them lunch. Absolutely annoying. So anyway, that's that little device that's right below the LED. We'll start chucking this thing up on. Actually, wait, I kind of want those. So we're starting our circuit with an LED. So I'm just going to draw an LED. Oh, we don't necessarily have it going to ground. Now, I know just from looking at the circuit by the way it looks and how it be, I know that it is. Okay, that's not the view I wanted, but that's actually not that bad of a view. The transistory doodle right here, I really have to use my pointing devices. My hands are like in shit shape after all the brake line work that I've done. We have the positive lead of the LED going into the collector, and then we have the base going to a resistor over to this capacitor, and then the emitter is going to... Yeah, this is getting weird. What is that lead doing? Well, that's the negative lead that goes down to ground. So we'll start over here. That might be an NPN. What is it? Okay, Y2 is written on this thing. Let's try looking up Y2 in the SMD transistor. This is a vague let me just get rid of all this. The numbering on a surface mount transistor is kind of vague. What is this still doing open? Oh my god. So SMD transistor Y2. It's a fairly common thing, but there are several different devices that can fit what exactly this symbol means, right, on top of the chip. Y2 SOT23 Zener diode, PNP. So we're either, well, SOT23 is the shape of the thing. It could be a Zener diode, or it could be, I'm going to go with transistor on this one because I think we got several of those. But yeah, we'll go with PNP. I really don't want to download the data sheet. Oh no, that's not SOT89. That's not even close. I clicked on the wrong one, that's why. Yeah, so that would be, it would be between 3 and 1, and we've definitely got something connected to pin 2. So that's not what that is. I clicked on Zener diode again. I'm dumb. SOT23 BL Galaxy Electrical? That's a... Ah, okay. So this is a PNP transistor. So this one is used slightly differently. This type of transistor would be subject to a circuit wherein it is connected. Here, let me just draw both of them. And so that one will be there. And then this comes out here. And these are the two different. So NPN. negative, positive, negative, positive, negative, positive, right? So that is basically how we dope the silicon junctions of these transistors. And basically inside of that thing, and the reason its symbol is a bar, is that you would have 3 pieces of silicon that are connected to one another. And so if you put current on the one, then you get flow through it, right? With the PNP, it works the same way, but the opposite. So when you put a ground, when you put a negative signal here, current flows from positive out in like a small bit, does that, and then a whole lot flows that way. So what you've got is basically the ability to switch positive to stuff instead of negative, and it is triggered by a negative signal over a negative bias on this pin. So this one, you would have a resistor here that goes to positive, and then this would end up going to positive, and then you would that would keep it unswitched until you put a ground on it. I'll just draw that there. And then the transistor inside of its little shell, that basically looks like the same bullshittery that we have to deal with, which is where you have pin 2 is the one with the arrow. So this one goes in, and then there's the thing that, damn it, hold on. It has to be like, bleh. No, hold on. It's always hard to draw because your transistor has to be like all cockeyed. And then the arrow goes in. God, that is annoying. I guess it makes it easy. It makes it easier to be a switching device that way, but now if you're even confused about what I'm doing with these freaking hieroglyphics, know that this is a schematic. Every single line here is basically a connection. If I draw a dot over it, it means it's connected. If I have a signal cross like that, that means it's not connected. This is a symbol. This symbolizes an electronic device. This symbol right here is for an LED, because an LED, basically a diode, is an arrow pointing to a block, and that arrow is the positive end of it, and the block is the negative end of it. And when you forward bias this diode and get it over a certain amount of volts, power flows from positive to negative, and you subtract the voltage drop from that voltage. That's how diode do. These symbols were made up by ancient white people who were probably drunk, but they're as close as we can get to hieroglyphics, I guess. I don't know, whatever. Have fun on the holidays. Stay safe. Remember, being an order requires guts. Ugh. All right, Turvy. Good seeing you, though. Thanks for hanging out. Maybe ghosts built this device to throw the ghost hunting industry off the trail. Okay, now we're getting into the layers that I wanted to. Yes. Yes. It was Big Ghost. Big Ghost did this, and they did this to hide their tracks. So anyway, I like drawing. If I'm reverse engineering something, I like having napkin notes. So NPN, PNP, and the layout of the different transistors is something that I would like to have in my notes. I guess another thing that I could do is use the snipping tool and just get, where is that? Where'd my schematic go? Oh, that's my Osh Park. Wait, how's the Osh Park design doing? How's our electronics board doing? Okay. No updates. You guys got the last 4 numbers of my credit card. Oh my God. Just try to ignore that. All right, let's get this in there, but I don't want it to be obnoxiously large. I'm gonna do that, and then I'm gonna do the snipping tool. Oh, there it is. I wasn't seeing it. We'll just get that. Even though that's, I mean, you can pretty much just have that memorized. And by looking at the circuit, we'll kind of know that that's the structure of that. Okay, so we got all that stuff there. I'm gonna close some extra windows. All right, so let's take a look at the circuit itself and let's figure out what's connected where. Generally, I would start with the power, but with this thing, I mean, we kind of know that the battery goes in, battery goes out. You can't explain it. So we're looking at the first LED, and we're starting there. So it's going to kind of branch out in both directions. But I see a resistor that's permanently connected to ground coming off of this. So the negative leg of the LED, so it makes sense that there's a PNP on it. So the negative leg of the LED is going to go to a resistor How do I know that's a resistor? Well, they're pretty universal. They just look like this. Capacitors in surface mount look like tan blocks, whereas resistors are a little black chip thing that has a number printed on it. And that number is beautiful because what it does is it tells you the exact resistance. God, I'm so glad we're not dealing with the color stripes anymore. I hate those things, not to mention the fact that there are some pretty awful acronyms that people have come up with. Just to remember Roy G. Biv, it's stupid. Anyway, so this thing right here has 1201 printed on it. Bother, does that mean that it's 1,201 ohms? No. What that means is it's 120 with a singular 1 at the end of the number. Now this is, I mean, people say, hey, it's the how many decades, whatever. It's the number of zeros. Just think about it as the number of zeros. You don't need to involve math. So that's a 1.2 kilo ohm resistor, 1.2K. Given that the circuit's probably 9 volts, I guess that's a reasonable amount of kilo ohms on that. So the British way, or sorry, the European way to draw the resistors is to draw a box. But I am so American that I have to make everybody annoyed with me. So I do blah, 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 and then I always make them look like shit. So here's our resistor, and that goes to ground, and that's 1.2K. I don't even bother to draw the ohm symbol because we know what that is. All right, so up here is where we now have a transistor connected to this thing. So we need to take a look and see what this looks like on the microscope. So we got a base, we got an emitter, we got this thing, we got that thing. Where is this trace going? This seems to be a more universal trace right here because we've got vias on it. And this looks like they could have probably done this in one layer. They decided to go with two, and they've removed a lot of the, what could have been, what do you call it? What could have been ground planes all over it. So we're not really tying a ground plane into stuff. We're just cleaning it up over by the LEDs. And I guess over here they said, you know what? No. After teaching, are we going to build another one? I just really want to know how this thing works. I want to know what the nitty gritty of the circuit is. We've got this PNP transistor here on this LED that is never going to turn off. Supposedly. Just another guy named Harry. That's a good Twitch name. Pull the lever, Kronk. Okay, so we've got this trace right here. Let's verify that this is power. This is going in a bunch of different directions. Now these vias are basically rivets that go through the circuit board. They take us to another layer. I have a feeling these are going to pop off in the middle of my using this circuit because we're going to be flexing this thing a lot. They put, I don't think that's glue actually. I think this is flux. No, it is actually glue. So they put a modicum of glue directly on the contact and not where the wires will flex. They could have put a hole through the circuit board and used that, but it's like a warp pipe. Warp pipes are hard to trace. I used to work in warp pipe engineering is a very complicated subject. See, this isn't glue. This is just flux left over from what they did. Is that there's a machine called a pick and place that puts all these components down for the surface mount stuff. What they'll do is they'll put the board into a machine and that'll etch all the stuff and do all that complicated stuff and put the vias then get plated in and it'll do the solder mask and the silk screen. Then they have a pick and place. Well, they have a kind of like a screen printing thing. They have like a metal screen that they put on top of the circuit and then wipe a bunch of solder paste across it. That deposits solder paste on all the pads that are designated in the schematic or in the design files to have those pads. Then a pick and place will pick up individual components and place them all down. Then it gets put through an oven and all of the solder things are soldered except for the through-hole parts. So through-hole parts, things that are a bit complicated, they're not necessarily to be done with an automatic process. You'll have people sitting in seats soldering over and over through-hole parts. And they'll solder these things and there'll be flux involved in that and it'll get left behind. So they don't put it through a cleaning process afterwards, and that's how they preserve all the plastic stuff in the where solder exists. Now you can automate through holes as well. Automation with through hole devices used to involve an actual wave table of molten solder. You would have this long table that would be filled with molten solder, and then a wave of solder would travel across the table. And if you put a circuit board with a bunch of through hole components through that, it would deposit solder where all the through-hole components are supposed to solder. But if you overdid it, of course, you could throw the parts off. And if you have surface mount, it'll just wipe them away. I'm getting lung cancer just thinking about that. I'm sure the ventilation was great for wavetable soldering. I'm sure it was great. I'm totally positive that it was completely fine and great. So yeah, we've got a PNP transistor here. That Y2 marking seems to be appropriate. Oh, we didn't even trace this back. Where does it go? It goes up and around. What? Huh? What? What? Huh? It goes to the positive? What? Okay, I guess that goes up and around to the positives of all the other LEDs. This is the only one that's switched with the way it is. Blockchain just subbed. I just learned more about circuit board production than I ever knew. I don't know how I've managed to do this, but I seem to exist in a space where there's just not a lot of like professional education. I hope that's changed, because I believe the makers movement has brought a lot of that stuff to light. And I never styled myself a maker. This is just the stuff that I would do. And my ability to break stuff down into simple terms is somehow like a superpower out here. I don't know, man. I didn't plan any of that out. I'm mostly just concerned with what kind of pizza I'm ordering tonight, you know? But I got into the groove of just like being able to explain this kind of stuff in sort of a relatable way. And somehow that caught on, and it's like shocking to people. So yeah, messages like that. I love you guys, man. I hope I am providing value to the Twitchosphere by doing this stuff. I just wish Twitch would notice me, and maybe I could somehow do something that would get a couple more viewers. But you know, the numbers that I've got are shocking for an electrical engineering stream. So I'm happy. You guys are great. You guys are great. Breaking stuff down into simple terms has always been a superpower. 28 months from a Bridgewater. It's hard for me to believe that. It's like being charismatic about electronics, I guess, is something that is a little bit more rare in this space. It's odd that it is. I don't see how that could be the case, but it do be like that. So yeah, I don't know. Hey, I'm glad you guys enjoy it. And you know, the stuff I say, I know a lot of you guys will hammer down the details on me. I'm trying not to get into that, you know? I'm trying to keep it simple. And hopefully everything I say is mostly right. And if I get it wrong, I'm sorry. I'm just some guy, you know? I'm not an expert. I don't have a degree. Wait, I do have a degree in control systems. All right, let's get back to what we're doing, because we got some circuit to get through here. So I'm looking for power. I'm looking for where power is, and it turns out all of these LED. What the hell is going on here? Whatever tool they use to do this. By the way, you have all of this space. You have all of this space. Look at all this space. And you decided to go up and around, use one size trace here, use two weirdo things that, then you double it up. And what is happening here? This is, I mean, this feels like somebody did a couple design revisions on top of one another, and they just didn't spend. We see stuff like this in this realm where people didn't spend time to sort of clean things up. It looks like they're moving as quickly as possible to do this, and that might be the case. Maybe they got a bunch of designs to go through that day. But there's a lot of electrical no-nos that we've seen so far on this, not to mention this right here. A lot of electrical no-nos, but I think maybe those electrical no-nos work to the advantage of the device. I unplugged the fart machine because we're doing reverse engineering and people were being kind of obnoxious with it. So that's one of our vias. Here's the other one. See, the thing is, you could have just dropped all this stuff to vias and done it on the other side of the board. You could have had power and ground only on the other side of the board. Whatever. Anyway, we're coming over here via. We know that goes to all these powers and nowhere else. And then up here, now I'm ignoring these resistors right now because they're going to the base. So we'll get to those in a minute. But we're just taking this as being V plus for now. We're going to see if they do anything special to V plus. So I've got a via here, and then there's another via up here. So we're going for the one closest to the edge of the board. There's our V plus. Oh, this is annoying. This probably looks a lot better when you look like in CAD program. Because like, okay, this is a symptom of this was designed in a program like Fusion 360. In Fusion 360, no ground plane on the lower part of the board, and traces making weird jumps to the other side of the board with barely anything going on down here, except for these are looping around the board. Are these antenna? These might be antennae. What the fuck? Yeah, so stuff like that. I'm sure this board looks a lot cleaner when you view through the board from above, like in a CAD program. All right, so go back to this one. Yeah, regardless of whether or not they're intended to be antennae, they are antennae because they're looping the whole board. We could measure them and figure out what kind of frequencies they're sensitive to. All right, so anyway, we're looking for power. We're looking for power. We know it abhors a vacuum. So there to there. What? 3301? What? Huh? Okay. So 3.3 kilo ohms and nowhere else. But it does other stuff in there. Okay, so let's mark that down. So we have our power trace, or wait, we have our positive trace of the LED that goes to a PNP. It's dynamite. That goes to some stuff. And then we've got a 3.3K. Let's look at some of that other stuff so I can just mark it down, because that is also involved with the base, the left side of the circuit that I'm drawing. With reverse engineering, you are just trying to get all the details down. You will have to then go through your schematic again for clarity and redraw it. And generally what I'm going for in the schematic is power in the upper left, and then in sort of a cascade from the upper left to the lower right, you have the functionality of the device. So you go from your sources to your functions to your outputs, going diagonally or horizontally, just like you're kind of like reading a sentence, right? Kind of like the way you read a page. That's what I go for. There are all kinds of other conventions when it comes to schematics, but if you want to be able to communicate easily to an engineer, that's generally the direction you should go. And there are certain types of circuit structures, like for instance what I'm doing with the transistor, that you'll want to piece together in order to communicate to an engineer what exactly that circuit is doing. Schematics are communication. They're a log of exactly what is in your circuit, but they are also a communication device for what is in your circuit. So you gotta write them like a sentence. So all right, you wrote like a sentence just then. So we're going into a giant capacitor. That is a very large capacitor that looks like it goes to ground, and it very haphazardly goes to ground, just like all the other ground planes in this godforsaken fucking ghost hunting device. So this is going off this way and then back over, and my supposition, I'm making an assumption that that is then connecting to ground. It's doing it in the worst way possible. There should be a ground plane, but I guess there are 4 giant antenna lines out here, and any noise this circuit makes is an advantage. So we've got a capacitor to ground, and we've got a 3.3 kilo ohm resistor. Well, actually, so 3.3 kilo ohm resistor on the base. So let me go back to my other view. I keep moving this window around and it keeps going in weird spots. So we've got a 3.3K as our first stop. So this is the current limiting resistor for the transistor. If you don't have that 3.3K there, when this thing goes to ground and it starts conducting electricity, you can get too much current through your transistor. It can heat up. So you want to have big resistors on your base because you only need a trickle. You'll need a little tiny bit of power going through there. Yeah, I think $24. How much did I pay for this thing? Hold on. Let me open up the Amazon link. I think I need to reopen it. Yeah, I don't have it open anywhere. Hold on. How much did I pay for this thing? because this amount of money for a one stream project as a curiosity is kind of bad. It's kind of bad. I'm losing money on Friday, but it's the holidays and I figure I'll do something weird and fun, like take apart a ghost hunting device. $25. 25 I think is kind of reasonable for this level of analog circuitry. The one that I saw on the YouTube video actually had like a specific, like, bespoke, it had what's called an ASIC, an application specific internal application specific integrated circuit. Whoa! Oh, my brain. Hello brain. How are you today? I am bad. Oh, good to know, brain. Thank you. Yeah, application specific integrated circuit. An ASIC is when you have a job that you need doing that isn't just like a generic job. Like a comparator is not an ASIC. A comparator is for comparing voltage levels. It's used in thousands of different things. But a chip that is designed to take an 8-segment display signal and turn it into a 4-segment, like a Nixie tube operating circuit, something that takes a binary coded number in and switches transistors in order to light up neon plates inside of a Nixie tube. That's an application specific integrated circuit. It has one specific use that it's supposed to do. That doesn't mean that you can't do other stuff with it, but that's generally how you have ASICs, right? Yeah, I was actually working at a gig that did that. Some of the guys from, what was the company that got bought out by the Chinese so long ago? I think it might have been like Sound something or other. They were like the sound card guys that then got fired, and then they were hired by a company that was doing audio over Ethernet, and they were sort of like the first name in audio over Ethernet. And so what they were doing is they were taking their FPGA design and they were turning it into an actual chip that would take channels of audio in and turn it into like an Ethernet cable. It would fit onto an Ethernet cable, but it would take your high quality audio to different places. And so they went through that process, and they had what I call what is called a glob top, which is just a generic chip, like a big chip epoxy case, and they put your custom die on there, do all the bonding wires, and then inject a bunch of like epoxy on the top, and that usually has a wavy surface, so they call it a glob top. Anyway, chip on blob. Well, it wasn't a chip on a PCB and then a blob over top of that. It was a chip, or like an IC case. Something just moved on my floor. I think I have ghosts. How's the window doing? Okay, the window. Whoa! The window is moving. Oh wait, no, it's not. No, it isn't. Okay, the window's not moving. We don't. I let my guard down, and then the ghosts come in. But yeah, they would take something that looks like a chip, and they would plop the silicon on it, and then glob over that. It's not the cheap circuit board where they just put the chip directly down the circuit board and then put stuff over that. But this thing didn't detect that ghost just now with the thing moving on the floor, right? Unless we didn't catch it. Maybe we weren't looking hard enough. This is supposed to be a ghost counter. That's what they said in the Amazon auction. Amazon's not an auction. What's really going on, Amazon? So we have a 4.7K pulling up that line, we think. Actually, it goes to a capacitor and then ground. What does that other part of the thing do? We don't know. So yeah, here's the circuit so far. So we have here, and then we have a 4.7 going to here. So this is a filter of some kind. These are looking like your typical sort of transistory circuits going on here. Now the base does not do much else, does it? The base goes there, and then it goes to this, which I believe is going to be a pull-up, and the big capacitor to ground. So we'll do this. Now, I don't do more than 4 junctions on the dots. That is a very specific, that is a very, very personal thing that I do. I take it personally when there's 4 devices connected to a junction. And that comes from me having to author thousands of schematics that are supposed to look like one author made them when you're a team, and trying to keep the communications as clear as possible on them. There's a lot of mistakes that can happen in that sort of space of is that actually a circuit junction? All the places you see 4 lines going in will be non-connecting, every single one, unless you allow there to be 4 connected lines on the same dot. I don't. You have to back me into a corner and I'll probably scratch you a bunch before I do it. But anyway, we don't need to do that here because we just have this electrolytic capacitor. Electrolytics get the little swoopity-doop at the bottom, and that goes to ground. And, you know, in the typical parlance, you'd put a plus on the plus part of your electrolytic capacitor. A ceramic capacitor doesn't have polarity, and it's just 2 plates, because a capacitor literally is 2 plates. We started with Leyden jars, and we moved our way up to where we have still 2 plates. We have 2 plates with a piece of cardboard in between, and then they're rolled up into these little cans that you see everywhere. And if Denethil was in chat, he would probably link to the exploding capacitor incident. This one is marked with 220 16 volts, so I'm going to assume this is 220 microfarad 16 volt capacitor. For the purposes of our exploring this circuit, we do not necessarily need to jot down all of the information about this. I'll put it in there just to be thorough. So 220 oof, 220 oof, 220 UF 16 volt. The only real purpose that I could see, well, okay, anyway, well, this is on a timer. Wait a minute. That's essentially, well, we don't know what's going on up here. We don't know what's going on after the 3.3K. So let's go ahead. I need to turn these into transparent. Yeah, 2 plates to 2 more, two plates. There's still 2 plates. There's all kinds of other capacitors out there, though. We don't need to get into that. I had to dry out my pump house today. Burst the pipe. Notice the circuit in my pump only had a very large capacitor. I made sure no touchy. Yeah, you give it enough time and it'll discharge. The capacitor on a pump is, depending on how many phases the motor is, because that's there for the motor. What that's supposed to do is that's supposed to create a phase delay in the AC that's running the motor, and that phase delay helps the motor start up. If you look for, what's the guy's channel? He's got like the ponytail, and he's like real amicable, and he seems just like a big sweaty electrical engineering dude who's somewhat funny. His jokes kind of sort of meander around that dad joke territory. He does like, is it Everyday Electronics? Is that the guy? I'm trying to remember the name of the channel, but he did a really good one on fans, and why there are like the order of speeds on the fans, and why there's a capacitor on the fan. But that startup capacitor is very important for the operation of the motor so that it can get going, because it needs that extra little oomph in order to get that push so that the magnets can push. Technology Connections, yes, that's the guy. Big fan of saxophone music, that one. What does the circuit look like again? So we're looking for whatever the hell is happening on the other end of that 3.3 kilo ohm resistor that is not even anywhere around here, right? We've got this 3.3, then we've got a 4.7, and then we do some traveling for some fucking reason. I have absolutely no idea. He also likes the color brown. I thought that was fascinating. That was a great video. But yes, we're going for this one. This one. God, this is the hardest part about this. Now you can set things up like I have with a microscope, or you could set things up with a camera, and you can take a picture of both sides of the board, and with some minimal photoshopping skills, you can overlay the 2 layers on top of one another. And at times, in my most desperate hour, I would actually draw out all of the circuit traces. You could also do a high contrast to try to take out the, to isolate these in the photo editing software, and then you can draw the resistors and capacitors on top of the components, and then you can sort of clean up those connections and get a good idea of how the circuit operates. I don't think we're going to need to do that, because this will be separated into 4 different parts. But okay, our first circuit's going over to here, and then it goes all the way over to here. Then it goes to a 3.3K resistor, and we loop it around. Why? Why wouldn't you make that a little longer and just go, all the stuff that I tried not to do with my design. We go to whatever the hell this thing is. That is a Y2. God, we got a Y1, we got Y2, we got Y3. Well, I'm going to guess Y2 is an NPN. So we're looking up a Y2. We know that Y3 is a PNP. This is Y2 SMD transistor. I guess it's already in there. Another PNP. It's just a PNP with a different specification. Maybe. I try to find the right camera. I don't know. It seems like their goal here was to spread the circuit out as much as possible to encourage it to be susceptible to noise. I think that might be that might be the goal here. What was the other one? Okay, hold on. Micro, bring our micro. Ooh, it's getting cold out as the sun goes down. That's not going to help me. Wow. Oh, it was a Y2. So we've got another NPN transistor. Okay. That's a little weird. So we go to a 3.3, and then we go into the collector? Wait a minute. The collector of an NPN transistor. Uh-oh. Collector of an NPN. Yeah, it's getting cold out there. 3.9. Oh, 000. 3.9 M? Hold on a minute. $390 kiloohms for 2 of these circuits. Well, actually, for a bunch of them, because we still got more vias here. We don't know where this goes. Weird. Okay. So let's get 390K. That's a very large resistor. So, sorry. Boop. So the 3.3 goes off to La La Land, and then I'll just put, well, I'll bring it over here. I'm going to bring it over here, and then we'll put a 3.9. We probably don't need that there, actually. That looks terrible. Hold on. You look terrible, and your circuit's terrible, too. I had this thing where I had to build a particular type of design of a triggering mechanism. Hold on, 390K. Like a full system we had to replicate. So I had a lot of work with some of the circuits that we commonly see. I spent all this time designing it and putting the whole thing together. And I made the final device, and I bring it over to my boss, and I go, here it is. He said, this is what you made? And I'm like, yeah. He's like, try again. I'm like, what? Like, I involved like multiple teams of people in order to create the circuit boards and stuff. He's like, no, make it look better. I'm like, so I had to go back and like revise all the project boxes and stuff, and like print out labels on it and put labels on it and everything. Oh my God. Maybe do all of that finishing work. So we have a 300 kiloohm resistor there. That's a big resistor. That is coming back over to this sort of nimbledy-pimbledy, what the fuck is going on here? It's like a little dance, a little song and dance from all our components. Well, it looks like we got the comparator on this part of the circuit. This is weird. Okay, so it's like they were just like throwing components out into this design. I'm curious as to where R18 is leading on its other side. Let's trace that real quick and just figure that out. R18 goes in the circuit a little bit more. So R18 is going over here. It might actually be connecting to one of the transistor outputs. It might be connecting to R19. What do we think? R18 connected to R19? I gotta turn this off to use the multimeter. So we're gonna bring the multimeter into this, and we're gonna put it in ohms mode. I do not use the beeper. I'll tell you this right now. I never use the beeper. As somebody who worked in an office that contained primarily people trying to figure out what was going on in electronic circuits, anyone who used the beeper was immediately subject to having coffee poured on their shoes. I just can't stand it, all the beeping. So we don't use the beeper, but there is actually a functional reason that we do not use the beeper on this device. This is a multimeter. The beeper is designed to tell you whether or not a circuit is connected in the diode mode. We're not looking for diodes. The only information that that beep can give you is whether or not a certain amount of volts gets through. If there's a very, like, almost no voltage drop on there, you get a beep. We're not looking for that, though. We're looking in circuits that primarily consist of resistors. So if we go to the ohms mode, we're looking for a very low number of ohms on our connection. If we get certain other amounts of ohms, that tells us about what's connected to that branch of the circuit. For instance, if I connect this thing to a small ceramic capacitor, you can watch the ohms grow as the capacitor charges. Because as the capacitor charges, all that opposites attract and repel kind of nonsense. When your capacitor charges, like your decoupling capacitors, specifically when your device turns on, power goes to the one leg of the decoupling capacitor, and it goes through the capacitor to ground all the way up until that capacitor charges in like nanoseconds. Once that voltage level reaches a stable point, and this is the whole point of the decoupling capacitor, that capacitor is charged, and so no voltage flows through the capacitor. There's maybe a little quiescent current that goes through it, but we don't talk about that. What it does is it basically means that while your power supply is coming up to power, all of your circuit component is blocked from that power coming up. When you power a more complicated circuit device like a microcontroller and you have power coming up, different parts of the microcontroller will power up at different times in nanoseconds. This is unfathomable amounts of time. But what that can do is that can mess up your electronic circuit, and it can have it be like, hey, my memory says I should do this, but this part isn't powered up yet. So it can cause all kinds of problems. You put a decoupling capacitor on that, then your circuit is hit with the full brunt of the power supply. In our case, the capacitors here are probably just hit there to confuse the circuits, make them operate just a slightly different way. But if we use our multimeter in ohms mode, we can tell if we're probing around for stuff, if we're looking at pins on a microcontroller, if we're looking at a capacitor, or sometimes you get an even value resistor and you go, oh, I'm looking through this thing right there. So that gives us one more piece of information that we can utilize. My friends were insulting each other in Morse yesterday. Whew. That's a special thing. Those are nice needles. These are the high voltage probes that Fluke sells. I like them. They allow me to stab through stuff because there's a little flux on the circuit. You just saw it break through right there. Hey, they're your friends, not mine. 155.1 kilo ohms. That's not quite this. Or is it? Hello? It is. See that? Got that piece of information. It told me everything I needed to know, even though this is a really weird precision resistor. 1183? Is that really 155K? 152? Those are not the numbers that I see in front of me. Who's making these resistors? Jeez. So from here to here. So we're doing multiple things. We're going through multiple branches of the op amps here. Whatever is supplying this thing is kind of weird and complicated, but we'll look up a couple circuits when we get to know this a little bit better. So we have the 390 kilo ohms coming in, and it's going to this pin right here. What is that pin? Well, we just have to go back to this drawing. Go over here. So pin 1 marked with a swoopity hoopity boop. So that thing right there is actually the bar in this case. Well, actually, is it? Hold on. Slightly conflicting information here. Because of the way this thing was molded, we have a little bit of a break in the back end here. That could be interpreted as being the little cutout for pin 1. However, we have a big bar over here, and the text is reading in this direction. Not to mention the fact that the schematic doesn't appear to have a bump there. The schematic would have a bump on that end of the, see that? It's got the bump right there. You can see the two the two pieces of the, not the schematic, the solder mat, silk screen, the silk screen layer. So the information on the silk screen layer is telling me that pin 1 is right here. 1, 2, 3, 4, 5. Pin 5. Pin 5 is the positive end of one of the comparators. I don't know. Sometimes I will flip the comparator in order to make it draw a little bit more easily, because they sometimes flip these. So I'm going to do this for now, and we'll see if we need to redraw it. So this would be plus, this one's minus, this one's pin 5. I believe the next is pin 6 and then pin 7, right? Yeah, pin 6. Ugh. Pin 6. Pin 7. Ugh. It's not like I'm hand drawing this. Why walk? I always ask myself that. Sub to the Prime for 12 months. Why walk? Thank you so much for the Prime sub. I appreciate that. I gotta actually close the window because I'm fucking freezing. I'm the only person in the house and there's not even heat. It's just me and ghosts. Yeah, I'm also home alone, so it's actually kind of fitting that we're doing a ghost hunting device. My puppy dog is in Maryland with my brother for the holidays. Poor baby. I can't see her. She's not here. Is the ghost in the room with you right now? So no more wind blowing open. No more wind blowing open. It's finally above 0. I don't know what the temperatures are. I'm just cold. So we've got 1 amp doing that, but then our circuit branches off. So let's see what's going on with that. We'll just get this specific branch. You can see all of the dead ends that I've got so far, but we'll get to the bottom of this. This is going to start looking like an actual circuit structure in a little bit. I'm sure of it, maybe. I'm not that sure of it. I split a nail. Oh, these fucking ghosts. These fucking ghosts will get my flush cutters and do my nails. All that car work led to gross nails. And I cleaned them, made them weak. All right. 15F. Okay, fine. I'll check. Forecast. I hate that Forecast IO is shutting down. I hate it. I guess they keep pushing the date out though. Yeah, so supposedly it's like 17 here, Fahrenheit. Our lowest is at 2 a.m. It's going to be 8 degrees. I put the car in the garage though. At least I got that going on. I hope she doesn't come back with an accent. Oh no, she loves crab. And she made it part of her personality. Nobody's getting out of here alive. Why would that op amp have a branch that goes out to the red LED? What the fuck? What is happening here? No! Old Bay blood. Oh no! No. Okay, something else is happening here. Because we're coming in from this branch of the circuit, we've got a 3.3K, and that leads to another PNP circuit. Jeez, there's a lot going on here. N3, what is that? That's a Y1. Maybe NPN. They're labeling their transistors as Q, but then we've got an N, which is not usually a What? No, this is a ghost hunting device. We're hunting ghosts. See that? Ghosts. Look at all these ghosts. I wonder if the circuit that we're looking at right now has something to do with the startup sequence. Like as that capacitor charges, if that's going to be doing something to it. Well, we need more information before we get to that part. So we're here, and we're looking at what's happening after this 390 kilo ohm resistor. Boy, I'm cold. I'm freezing. We come out to this absolutely atrocious looking branch. One of them goes to one of the comparators. The other one goes to, the other part of the branch goes to a 160 kilo ohm that goes to another branch. So 390K goes to one. Let me, I guess, just draw the other one on this. We could be looking at a power trace and maybe I missed a detail. Because if all the negatives of the comparators are going one direction, maybe they're just aping off of this branch of the circuit right here. So I'm gonna actually draw all the way over here. We'll do another like that, and then we go to 160K. I have a feeling the values are going to get lower and lower. And then that goes to what branch? That would be another plus. Yeah. Yeah, this is the supply. This has to be. I think I missed something along the way. Cuz like this one goes to another resistor. And I'll redraw this in a minute, but that one goes to another resistor. We'll just, you know what? Take this. Put that here. That's a little close. 390K is not the value. It's a 160K. And the numbers are 1098. So it's going to be pin 8, 9, 10. Bother, why don't you do this in CAD software? Because fuck you, that's why. Okay, that's 8, 9, and 10. I have a feeling the next branch, which is also connected to this. Where were we? We were Wawa. This one. So we've gone from these two, that resistor, and then this one goes, it's on the other side of that resistor. So that one goes to the branch, but then this goes here, and there's another resistor on it that goes to the other positive. Where does this go? So let's just determine this one is 1183, so 118. Why are they like this? That goes here. So it's on the other end of the 160. How am I supposed to draw that? Well, let me get it jotted down. I'll just jot it down. We'll do a junction here. And I'll go up. Like I said, no dots. The dot means that it crosses over and it does not connect. That's why I don't do four-way junctions. So we'll take this again. I'm gonna cough 1 sec. It's getting cold and dry. That's the ghosts, and totally not related to the weather. That is actually the ghosts in here. So I'm in a very ghost-heavy house. It was built in the 90s, so there's a lot of, a lot of people, like a lot of like Spice Girls getting sung by goats. That's ghosts. Why did I say goats? It's like 115K. That's what we measured. It's not what's written on the thing. But the pins, what are the pins? Pins are pin. That's 14, 13, 12. Later, Kervos. Weather is actually goats. Oh yeah, I know how I know what pins there. Oh, you're not in the right. That's actually Europe. That would be 14, 13, and 12. 14. Wait, did I get those? 13, 12 would be this one. Yeah, I got it right. Now, one quick check. Oops, check. To see who is connected to the other side here. Whether it's this is connected here. It is not. It might just be floating. I don't think they floated it though. Nope, that's 0.3. And what about you and you? 15 kiloohms. Who here is 15K? Is that going out here? Wait a minute. That'd be a really weird, I mean, this resistor is really weird too. I mean, why is this resistor all the way out here? Why not move it up that way? Why don't I use something like multisim to do what? We don't need AI tools to tell us what's going on here. Yeah, for some reason they ran this resistor all the way out here. What the hell? R20 is connected just between these two. Okay, strange. So wait, this one connects to there, and then that one, and then there's a resistor. I think I messed this part up right here. No, wait, 390's over here, and then 160 is coming off of that same junction. So I guess that's fine. No, it's not. It's not better than paint. It's impossible. Can it do this? Didn't think so. All right. Yeah, totally obliterated. There's nothing left. There's not even a corpse. Like that. And then the value of that resistor, 150200. So 15K. And then we'll take this and we'll just renumber it. And then I'll take these away. English only, please. I now have to take what you said and go to translate.google to make sure that you're not cursing. Okay. I would appreciate English, because then I can moderate it. Boop, 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 boop. Okay, so those are what pins? Those are pins. Is that 1, 2, 3? Yeah, that's the first couple ones. So that makes it pins 1, 2, and 3. So pins. I draw these upside down. It makes the circuits easier to draw, but in this case, I might have to flip them over again when we discover what the hell is going on here. Because, I mean, we can see the resistance to each of those positive branches gets larger and larger. And I'm going to assume that that has something to do with how this thing is treating the various levels of EMF. Because we're not sure if anything is connected to that pin 2. The negative pin might just float. It was actually cursing. My translation said, "I'll be there." It just says, "I'll be there." It thinks it's Vietnamese. What's up, these guys? It's not cursing. All right, so interesting circuit structure here. What are the outputs of these comparators doing? I don't know, but we're not concerned with that yet. We're still trying to figure out what's going on down here. So this branch of the circuit, we've got this line right here that seems to be supplying a cascade of resistors there and one big resistor here. So I'm going to assume something else is going on with this line. Let's really vet out what's going on the other side of the 3.3, the 390, and the 160. Because if that becomes positive power, I need to redraw this section. What was the view that I was using? There it is. So we're looking at the junction of the 160K, etc., etc. Omelette du fromage. Good episode of Dexter's Lab. I'll move this over a little bit so I have a little room to work. So it is, what is the junction that we're looking for? Well, this is part of the cascade. This right here is after that. This is the one resistor, and then this right here is the question mark. And so this goes to several locations, including a transistor. Where does this go? This does a little hoopity-joopity, and it comes out right there. And then that goes to a bunch of different stuff again. But it's also on the positive lead of the negative lead. This would be the cathode of the Zener diode, because the Zener diode operates upside down. You flip them upside down and they go, what the fuck is going on? And what they do is they keep you at a particular voltage level in spite of what your input can do. So if your Zener diode is like a 2-volt Zener diode, in spite of having a 9-volt battery connected to it, it will only allow 2 volts to be present at this part of the circuit. Dog hair! Yeah, your dog hair, dog hair, dog hair. Down and around to the positive lead of a capacitor, to the positive lead of a capacitor, and then nowhere. And then it vanishes. It's gone forever. Gone forever is the output of our circuit. Billions and billions. I can't flip the thing anymore. Okay, it doesn't go anywhere. What the fuck? What the hell? What? Oh, so it's coming from over there. Or well, it comes in here and goes there, and then there's the Zener diode. So I'm putting this together in my head right now just by virtue of memorization. But we're coming in, I believe, right there. That's the one. And then doing that just hideous trace work right here. This is a product of viewing your board. Sorry, I put having in there and it really confused the sentence structure. This right here is a product of viewing your board through all of the layers at once and trying to make a clean circuit that way. They came out at a weird angle. They didn't have to do that. You could flip this, just mirror it, and just come out that way. This is why it's really important to look at your board layer by layer and turn off the layers that are creating noise. Really, it's not that important because this thing still functions, but my God, power has a long way to go there. All the way. Wait, what the? Uh-huh. Okay. Did you guys catch what just happened there? The positive power lead and or maybe just an antenna lead down and over and up and over and up and over and down and over and up and over and up and over and down and up and that's down and over and up and over and up and over and down and over and up and over and to the big dot. Big dot. Transistor. I still haven't fucking found power yet, and I'm starting to get pissed off. I'm starting to get angry. Chat. Starting to get a little angry. Why does our antenna go? What the hell is happening here? So, in order to draw this, I guess I'm just going to put a big fucking coil over here. It's not a feedback loop, it's an antenna. Fuck that. Hold on. We need like a... What is that? That looks like a tag, RFID. So RFID schematic symbol. RFID antenna. Antenna. Doesn't look like the engineers really like to draw the symbol. Typically, antennas are an arrow with a line in the middle of it. So your antenna symbol is usually going to look like this. It will be doot, 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 doot. But and then it'll come out of here and you do ant. A-N-T. But this isn't really an antenna. This is just a ridiculously long trace. So I guess what I'll do is I'll just draw it like, do 4 loops. And just like exit. Nope, shit. 1, 2, 3. There. I'll put a big open dot for that dot on the thing. It resembles an RFID reader, but it's totally kooky what it's connected to. I mean, I'm thinking like maybe I need to make a circuit junction out of it. We just started at an LED, and I expected to be seeing a little bit more LEDs out of this. I mean, we've got 4 comparator circuits that I think are comparing like other noise. Why do we have this thing? Maybe we'll get to that in a little bit. But I mean, on one end of the coil, and this is before, or sorry, this is after the coil. So we actually have the coil here, but then we also have 2 capacitors and a Zener diode sitting over here. There's a lot of other stuff that's connected to that part of the circuit too. So we've got a capacitor here. I think goes to ground. I need to verify that. We got another capacitor. And then the symbol for the Zener diode is actually going to be this, this, and this. It's just got the little funky arms on a regular diode. And then that goes to ground. The really, really shitty ground plane that we have to deal with on the circuit. There's other stuff that connects too. That's why I thought this would be positive power. And I guess our positive power is just a wibbling coil antenna line. They're just trying to give it as many opportunities as you can to get random EMF. If the power trace has to pass by the same location several times, it'll think it's lost and ask to pull over, and that generally is the beginning of your horror movie. So yeah, I think you're right. It is to encourage ghosts. So there is a transistor on the other end of that. How do we draw that? I guess that's going to be, is that a Y2? Yeah, that's a Y2. So it's another PNP. Oops. So yeah, I'm just gonna reuse my symbols over here and just take this, because that, which one is it? That's the collector of the PNP. I'm gonna need more room. This circuit is cursed. That's as much as we should have expected from what we're working on. This is generally what happens with these. The clarity will come from when we clean this up a little bit. When we know what's actually here and how the structure should look in order to communicate the circuit. Until then, we're wandering around this circuit kind of hooking stuff up and figuring out where it goes. Let's figure out where those come from, because I think those will go to the other LEDs, and that'll help us structure this a little bit more. So let's look. Oh, you guys weren't even seeing what I was. Sorry. While I was talking, I thought you guys were watching what I was doing. This is what I'm drawing for now. It's leaving a lot of loose ends and threads here. We will get to this, but this is what I sort of saw on my way through the coil. Very strange, and I believe we're probably going to be, but we're switching whatever's present on the coil out and away with that transistor, with that NPN transistor. I don't see it going anywhere else. That's the weird part. I'm supposed to, hey, you stop that. Fat and On came in and was doing all that negative shit too. I'm trying to be positive today. Listen to your podcast and post a dumb comment every few hours. What does this tool claim to do? Well, okay, so the tool itself is an EMF reader, right? It's reading the sort of noise that's present in a location. How it is getting the comparison of the noise, because we know it's using comparators to do all its work. What is it comparing it to? We don't really know yet. The Amazon listing for this device claimed that it was a ghost counter and had no further elaboration, right? It's all just ghost finder, ghost hunter, EMF reader, this, that, this, the other. That makes all the bogus claims, right? The device itself is performing the function that it was meant to perform, and I believe that is just to get like an ambient sense of electrical noise in an area affecting a particular line of the circuit, right? That's what we're looking at. The charlatanism and sort of the false claiming and stuff like that, that's happening between like the device isn't doing that. It's just the Amazon thing. I didn't look at the Amazon reviews, but how's Willow? Loving the pics on Twitter. She's not here. She's gone. She's gone. She's at my brother's for the holiday. She went, my parents grabbed her and drove her all the way down to Maryland, and supposedly she had a good car ride, and there was a picture of her playing with my brother's dog in the yard. I gotta send a follow-up. Sorry. Hold on, chat. You get the hold on. Super cute. How'd she acclimate? Nope, that's not the word. Swipe type. Acclimate. There it is. Okay, here's the picture. Wait, hold on. She's playing with my brother's dog. My brother has a Finnish Spitz. And so they're playing in this picture. It's not, I don't think my mother's a very great photographer, but it's good enough, I guess. They're getting along, I think. But yeah, they actually get to play in a fenced-in yard. It's going to spoil her rotten. Do you think this device was designed with a genuine purpose, or was designed with Ghost Hunter market in mind? I don't know. From what we're seeing, from what we're cute puppies, yeah. If you think that Willow is cute, join the Discord. I've got a channel there specifically for pictures of pets that you've taken, and so it's all my pictures of Willow. She's a very cute puppy, and she's completely and utterly become a part of the family. She's not here, and it's like too quiet here. It's too quiet. On the past couple streams, because she only like last week learned how to do stairs. She's been marching down here and hanging out with me. Last night, she marched downstairs. Like we went for a walk, came inside. I did a couple tricks with her. She went and drank water and hung out with my folks who were around. And then I came downstairs to work on some stuff late at night. So she wound up marching downstairs right after her walk, sat next to me, looked at me for like 2 minutes, started growling and barking. And I was like, you just went outside. I'm not letting you go outside again. So she flops down on her side in the position that I took a picture and grumbled a little bit and then fell asleep. I was like, oh, you did the toddler thing. You did the tired toddler thing. It was incredibly cute. I can't stand it. The dog is too cute. But yeah, she's wonderful. She's a great member of the family. I've been doing a lot of walking lately. A lot of walking around. It's been quite ridiculously tiring. Willow needs her own page. Well, okay, so while I've been streaming, she's been able to come downstairs and visit. In February, that'll happen a lot more because I'll have the place to myself. The roommates here like to close the door because I'm yelling at the furniture down here, and it's kind of weird to have this shouty man in the basement. But when we get to February, I'm here for a couple weeks solo, so we'll have much more puppy content in the near future. Now, there's so many components on this thing that we still haven't figured out. I thought we had a smoking gun right here with the Zener diode because we thought this positive power. Why did they? Oh, because they wanted this to go to ground. Okay, so that does to go to ground, but this one goes to the other end of the transistor. 22 off and 220 off. So 220 off. We got to spread this out a little bit. I need to be able to actually get values in here. Hold on. It always just spread out, chat. Just spread out. Just do it. Just do it. Just spread out. $220 so that's big cap. 22 off. And that, shockingly, goes here. So we're going to redraw that. So what I'll do is I'll do the coil, but we'll take it and rotate it 90 degrees. So in order to rotate in paint, you have to actually like isolate the thing and pull it out to where it's not going to get cut off. So like this, and we're going to rotate left 90. I'll leave the text vertical just so it looks super sloppy. Because that 220 off goes from one leg of the coil to the other. So we could do, I'm just thinking about how this is going to look. What are they going to think about me? How is this going to look? Actually, we'll rotate it. Rotate and rotate the coil. Rotate the coil again. My favorite quote, be the person your dog thinks you are. I don't know who my dog thinks I am. That's the thing. I am her favorite person, though, and that is just kind of amazing. Also, it's a lot of responsibility. Like I said, no four-way junctions. We got to get rid of that. The more we get into this device, the more curious I am about how it operates. I'll clean this up a little bit. This is like genuinely getting kind of confusing. Well, yeah, I mean, you know, you get a little bit of knowledge of MS Paint with this stream. That's added value for you, chat. That's added value for you. What the hell is going on? What is this crap? I don't even know, like there's a Zener diode in there. What is this thing doing? All right, let's, before I get, because there's a lot more circuit right here. There's a lot more circuit and a lot more transistors going on in this thing. So what I would like to do is figure out what's going on here, because I think that these things lead to the other LEDs, and maybe that'll put a pin on this thing. We're reverse engineering a ghost hunting device. There's no label about who made it. There's no markings on the circuit board about who made it. There's a lot of very sloppy PCB work going on this thing. This is courtesy of Amazon. It's just an EMF triggered ghost hunting device. It's supposed to, and again, the claims are not on the manufacturer of the device. The manufacturer of the device says, this thing detects EMF. There's no certifications on it. There's nothing. It's just like a $24 device, right? All of the claims are on the listing of the Amazon link that I followed. And the Amazon link says that it is a ghost counter / all kinds of other stuff. And also an EMF detector. So, I mean, it might be a useful device if you're actually building an electronics device that needs to not cause interference. Then again, if you're building a device of that nature, you would probably buy better RF equipment, like a frequency analyzer, a much better one. I was gonna buy a nice one. I had one in mind. It's $800, but it's a really nice one. Oh well. Oh well, LOL. Let's go back. We're going back to the chip. Because remember, we're basically revolving around the chip. The chip is going to tell us how this device functions, and we discovered that this is not an ASIC. It is just a comparator. The other version of this device, the one that I saw courtesy of a YouTuber, that one had an actual like EMF detector chip. This does not. It has a comparator on it, which makes this infinitely more interesting to me. We don't have to say, oh man, this is so much better than if it had an ASIC. I'm so glad, because this is a very confusing circuit. and we'll be able to look up and see if we can Google the type of circuit that it is. But first we need to discover how this thing does what it does. It appears as though all of the negative leads are connected to this branch of the circuit. And let's just verify that. So I'm going to verify that with a multimeter. And again, we're on ohms because it is more information than the beeper. The beeper is cursed. Do not trust the beeper. Those are defogonately connected. These are unbearably involved with one another. No, they're not. Hold on. What about you? Ah, plot thickens. No, wait. I missed. I got the wrong pin. We want this pin and this pin. Dear God, they're connected. Yep. Nope. Yep. Okay. So all of these negative lines are connected to one another. I can draw that in the drawing. I guess I have to. What is that going to look like? Well, I guess I can pull this one the other way and put it underneath. And that way all of these can go to one line. Yeah, okay. So we'll put this component over here. And I can put this component over here. We'll put it a little lower because I need to take this component without cutting off my 5. You cut off my 5. I'll never forgive you. That is a 4-way junction. Not allowed, not allowed, not allowed. It causes confusion. It'll confuse your circuits. We'll go like that, and then I'll take this, I'll lower it a little bit. Father, why are you using MS Paint? I don't know, because I'm good at it. Like, this is a napkin sketch. We need maximum flexibility. Sort of. I'm gonna, well, actually, all these are connected too, so might as well just. Oh, I missed. Ah. What makes the beeper cursed? When you're in a big office full of people using the beeper all at once, in addition to that, the beeper's looking for a diode. They added the beeper function to the diode function. That means if you've got something that has like some kind of a voltage drop on it, it's not really going to be detected. Like, it's just not good information. When you use ohms, you get more information. You get more of the picture that's there. For instance, you can see like, oh, I get 4K on this line. Well, that's going to tell you that there is a 4 kilo ohm resistor somewhere. I'm going to just redraw the whole thing. You get like a 4 kilo ohm resistor in there, and that's more information than this is connected, yes, no. I actually, earlier, I had a situation where I connected to one part of the thing, and it was actually 15K, which was the value of the resistor right nearby. So just go to the other side of the resistor, and then it's 4 ohms. So yeah, it's a very useful, ohms is so much better than a beeper. And you don't have your coworkers at your fucking neck trying to make you into a ghost for using the beeper. Move that out a little bit. It's a little bit tight. You're already, that's okay. That's true. It's true. I did what I could. I don't know what's going on the other side of these things. So that's what we're going to investigate right now. So I'm going to make myself a little bit of room. Remember, we don't know what this circuit is going to look like in the end. So right now, I just need to get everything down on paper, and then I can redraw it as a sort of coherent structure. Napkin drawings just be like that. That's how they do. I don't even know where power and ground is coming from in this whole thing, and that's usually where I start. I'm supposed to start at power and ground. But let's look at, so all those branches connect to a 3.330,000, actually a 33 kilo ohm resistor. So we've got a 33 kilo ohm resistor and then stuff coming off of every end. Going down there, likely to here, although it could go either way, so we'll have to ohm that one out. Just trying to get a better idea of what's going on. All of those are connected, and they're all comparing to what? Well, D2 is the only connection there, and that goes to another diode, and then it goes to another resistor. Holy crap. What does that fucking look like? Jesus Christmas. Okay, those are all the negative ends, so we go over to here, and so we're coming to that, which is 33K. And then we're going to a diode. Oops. That's probably a 1N4148, I would guess. And then there's another diode. And then what happened? Ghosts. No, and then what happened? Oh. What? The diode goes to ground. What? Wait. It's in reverse? What? Huh? Okay, hold on. I'm redrawing everything I thought I knew. Everything I know is wrong. So the band on the diode is the cathode, which is the flat, the part that the arrow points into. A positive, right? Anode is positive, cathode is negative. So that goes into the cathode from the 3.3, or sorry, from the 33K. And there's also, and I'll show you what I'm drawing in just a second. There's another resistor that goes to a diode in the appropriate direction that also goes to ground. So ground there, ground there. Weird. Why would you do this? And then that value is 3302, so it's another 33K. Huh? Wait a minute. What? This is what the circuit's doing. They both go through the same resistor, but they both go through a diode to ground. Let me just redraw that so it's a little bit more clear what's going on. We could just take that. It's like we're rectifying it. It's like a half-bridge rectifier. Still bugs me the symbol for a diode is the arrow pointing exactly the opposite of what you expect considering a cat's whisker setup. Yeah, I guess, yeah. Oh, but I mean, current going from positive, yeah, I guess current doesn't go from positive to negative, does it? If you think about it in the way that Ben Franklin did, which is the wrong direction, as positive to negative flows. Points to ground. Banned. Clipping diodes in an audio circuit? Perhaps. Now remember, that's just negative bias of the battery, which goes in all kinds of different directions. So this goes on kind of a bit of a goose chase to get to where it needs to go. So what is happening over here? Well, those still have stuff to do. So what's happening to that stuff to do? It's coming down and around, and it's going somewhere. So let's figure out where that's going. Let me get the multimeter. I really want to figure out what the circuit does so I can explain it to you guys and look really, really smart on Twitch. Generally, I don't look smart on Twitch. It's like kind of a rare thing. So it goes to the negative of a capacitor and a 1003, so a 100 kilo ohm resistor to ground. And then it goes through a capacitor to positive. So over here, oops, we have, I guess I can draw it, I suppose here. I'll just take it off of this and go to a 100K to ground. And then there's a capacitor, sorry, an electrolytic capacitor Those are SAD capacitors. Electrolytic capacitors are SAD capacitors. And the value of that is, those who have guessed 622 microfarads are correct. It also goes to that other stuff over there. And that is supposedly positive. We won't draw anything yet. This is getting weirder and more complicated as we go. So 22 UF. 22 UF, and we don't know where it's going because it has more stuff involved with it. There's more stuff. This is getting crazy. Eventually, we're going to run out of weird branches for this circuit to go in. Because, like, we got R12 going out there. We've got Q6 over here, and it's got, like, another junction on it, which may mean that this is some kind of a positive, like, this actually could be where positive power is coming in from the battery. It'd be nice if we knew that. Never mind, the battery's not connected to anything. There's no circuit traces that come out of the battery. No, yeah, it doesn't go anywhere. There's just simply no battery. Oh, no, there it is. It goes to the switch. Who would have guessed? Who would have guessed? Where does it go from there? This is getting more complicated. I wonder if we're going to do multiple streams just so that I can reverse engineer this thing. Oh, it's all over the place. Okay, so the switch, we're going to the left-hand side of the switch, probably here. So if I go from R10 to the battery, well, actually, if I hook it up to the active, I gotta unhook the battery for this because that'll influence the results. So from there to R10, push the button. It's a locking switch, so yeah, so I'm getting, hold on, fucking thing. I gotta actually push this thing in a little bit because there's a lot of flux on it. 0.4. Now, it could go other places too. I don't really see any other options though. Yeah. It only goes into the one resistor. All right, so let's start from the battery now. Let's make sure we know where the battery's going, because that'll give us an idea of what's connected where. Because it looks like the battery goes in and it goes, hold on, battery comes in here, 9 volts. There's a big resistor, but it also goes up to another PNP, and then it goes off in this direction, wherever this goes. It doesn't take the opportunity to go right over to here. There's a PNP that leads to the capacitor that we were just looking at. So actually, that circuit has like a switched junction and a 100 kilo ohm that goes off in a direction. That's a Y2, so that's a PNP. So again, switched by ground, but then we've got a 7.5K resistor going off and going to the emitter. Collector goes to 9 volts. Okay. Jesus Christ. All this stuff will come together, I guess, when we get the full circuit down. This thing is getting crazy. So we've got a battery. The battery symbol that I use is multiple plates. It's always the battery. Doesn't matter. You don't need more than 2. It looks like a battery now. I go ground. And this one goes to... Well, we can do... Also, it's uneven. Hold on. It's uneven. I can't live with myself. This is the work part of the... okay, chat. Sorry, I'm in my head a lot, and I'm sort of... My brain is moving faster than my mouth, and I've got the ball and shackle of chat sort of being dragged along with me. You guys are all very curious about what's going on, and you want to look at the little structures of the circuit and sort of decode them, as do I. We need to get more of the picture, and getting more of the picture is just straight up work. So what I need to do is start just going into all of this stuff that I haven't actually looked at and figuring out what the circuit structures are that are connected to it, and eventually all this stuff will sort of coalesce and become our full schematic. It's going to be a mess of a schematic. It'll be an absolute nightmare of a schematic. And then we can pick out portions of that to kind of clean up. When I was doing actual IED work, we would come up with that, and sometimes, what's up, race car? We would take the different parts of the circuit and how they connect, sometimes even just from a like a layered paint program, just overlaying where traces and resistors and stuff go. You would take it down to like a notebook page, and then you would put it into the CAD program, and then you would clean up the CAD program. Sometimes I'd even have to start a new drawing from scratch in order to organize the different structures of the circuit. It took a lot of revision to get stuff into form, and I did it for about 8 years, and I'm pretty goddamn good at it. But this is looking like something like that, because it's a largely analog circuit that we have to decode. So a lot of this stuff is going to be very cursed at first, and we'll get to the bottom of it eventually. That's just my warning. I won't have a lot of exciting stuff to go over. My computer just went to sleep again. Okay, I'm just making sure my computer isn't restarting itself, because I got ghosts. I mean, that's the goal, right? We got to make sure that we got ghosts in here. This is like the perfect device for this stream, by the way. This is the perfect device for the stream, because it's like stupid and debunking something that's stupid, and it's weirdly made. It's kind of like badly built, but it does something kind of weird and special that we're trying to uncover. So I love this. This is actually perfect for this this stream. So 9 for this specific channel. This is a 9-volt battery, 9V. The first stop on the 9-volt battery is a transistor, but again, we don't need to communicate what the first stop of this thing is. It's not like anything is what is it, decoupling this. We just have it going to R10 first. We get some other stuff over here. That little dot right there is a via that goes over here. What the fuck? To another resistor to ground? No. I refuse to believe. I refuse to believe. That's a ground? What the f... Okay. That one right there. Is that goes up to there. This one. It's ground. There's no possible fucking way that that's... Is that plane right there? This entire plane is positive power? In which case, I need to change one of my symbols for the diodes. I threw up in my mouth a little bit. Unless it's this. 100K. 1 0. Yeah, this. It goes to ground. I just need a better connection here. No, 82 kiloohms. I'm on the wrong thing. Is it this? Oh, thank fuck. Okay, yeah, it is that. Okay. All right, so that is part of the transistor circuit. So 4.7K on the transistor. So now we know what's going on here. So 4.7K on the transistor. So this will be I guess we could just do 9V as our power symbol. So that is the 4.7K, and so this circuit now changes. So this becomes its own thing, separate from the 33 point, separate from the 3.3K. We can now sever this part of the circuit. And by the way, this would be the what is it, green? Does it have any? I guess we're calling it. This is G1. So interesting. (9V). That is its own circuit. So the first LED does nothing. It has absolutely no purpose in the rest of this circuit. It is completely severed from all other functionality in this device. As I suspected, it is just a power light, even though they give it an ID. So we can just move this wherever we want in our schematic. I'll just put it over here. But basically, 9 volts is coming in on this circuit until this 220 UF cap charges. It's a PNP. Doesn't it go positive with a negative signal? It doesn't conduct more when there's more power in there. So shouldn't that eventually just turn off? But it turns on permanently. So do I have my transistors backwards? Because that is positive 9 volts going there. When you turn on the switch, positive 9 volts should be visible at the 4.7 kilo ohm resistor. That would cause current to saturate at the 3.3 kilovolt resistor were it not for the 220 microfarad capacitor there discharging this thing. And while that discharges, that would bias the PNP, because it's not an NPN, it's a PNP transistor, it would bias it positively or negatively, which would turn it on until the 220 microfarad capacitor charged through the 4.7 kilo ohm resistor. And now that there's a positive charge there through the PNP transistor is turned off. Current is not able to flow from base to emitter on that. Or am I thinking about this wrong? It'll turn on at first, right? And then it'll turn off. Because it's not, in the presence of DC power, a capacitor begins as a short circuit and then charges up. That's the whole concept behind, you know, like if you have an IC. A little drool coming out of its mouth, and you have your positive power, you have your ground, you would have a capacitor here as a decoupling capacitor, so that in the nanoseconds, as power comes up, this would act as a short circuit there, and it would just cut that to nothing. And so you would have no power, no power, no power, and then that thing charges up and you have full power. Are you certain it's a PNP? And do I have my switching circuits the opposite way? Because it would make more sense if it was an NPN. Maybe I messed up all of the transistors in the drawing. PNP are switching positive power in, and it's biased negative, right? U plus biased in, yeah. But what's the switching direction? It would be U plus and out, I believe. Maybe I got that wrong. I constantly confuse these two for one another, by the way. No, we only have the symbol on the surface mount device. So we only have Y2. What? Come on, man. The simple... Sorry, I'm just trying to look things up. It's always very confusing. Yes, everybody draws the two symbols next to each other, but nobody asks, how are the two symbols? I need the ones that... Here we go. So, in small signal mode versus switching mode, huh? It could be that we're on small signal mode, but I don't think I think those transistors are supposed to be the output of the comparators. So when the comparator gets to the right level, it'll switch. But then this one's just connected on its own. Because yeah, PNP is on when low, and then Y2 is typically a PNP transistor. Or a Zener diode, which we don't have. Well, it's not a Zener diode because we're using all three of the legs. So yeah, it is confusing to do this. This is why there's no shame. And you know, I've worked with engineers who will laugh at you for looking this stuff up. I don't think you guys realize that like the gates that I am breaking down here are big. They exist very big in this hobby, and people who are even professional engineers will confuse this stuff, but not admit to it, because engineers seem to have this weird thing about always being right, which they're not. A lot of egos need to be busted down. Getting this stuff straight in your head is very difficult. Even if you have a modicum of ADHD or dyslexia, it is very difficult to do. So it helps to pull up things that help you with references. I had a whole poster that was filled with comparator circuits in order to reference them and see how people put them together and make it look like. I've never seen an engineer laugh. They don't have to laugh. They just, you know, take pleasure in your misery in getting something slightly wrong. At least the people I worked with. So what I'm doing here, it's okay. It's okay to look up referential material and just make sure that you get things right. This is how I'm able to build a circuit the first time, is because I've made all of these mistakes and I've had all of the embarrassment of having all of these little things go wrong, or having your coworker point out that you got something wrong that makes your whole drawing need to be redone. It's painful, but anyway. Yeah, always look it up because people are wrong. I've had times where I've spent a long time trying to decode a signal, and then I mention it to a friend and he's like, oh, that's just what goes into an LCD display. I'm like, how the fuck did you, where did you get that? And he's like, oh, it's just what it is. Turns out he'd worked on the exact same device and just didn't mention it. And so he rolls in and goes, oh, bibbly bobbly, this thing is the wrong, and just walks away. And I'm like, you fucking asshole. Anyway, I got this right. So having a PNP biased to not be switching is like that, and an NPN biased to not be switching is like that, which is why this is infinitely confusing to me, because the 4.7 kiloohms is definitely going up to 9 volts. Then we have a 220 microfarad capacitor, and let's just double check that. Let's just double check that. Because we're looking at what's activating this one LED. We ended up reverse engineering a significant portion of the rest of the circuit. We will get back to that, but now that we've followed, we did what we should have done originally, which was to follow the power. The power is going to tell you a lot about the circuit. And so our power goes into the switch, and when the switch is swatched, it goes into this branch right here. Happens to hit R10 first, but it also branches over to Q6. And then it goes on a little journey, and that little journey ends up over here. So this actually becomes positive power. Was that what we determined? Did we determine that, or is that still on the fence? It might actually not go anywhere else than, hold on a minute. Let's do a little sanity check here. So here to sanity check, which would be here. Doesn't seem to connect. No, that's like 15K is a resistor, so that does not actually connect there. This is our positive power. It's going to this transistor first. That's not here, right? Oh wait, that is there. Wait a minute. So this going all the way over to there. Yeah, okay. So this goes to here. And it goes to here, and it goes to here. So positive power is on this branch of the circuit. Then we have a 3.3K resistor. We have a 4.7 off going up. We go to the positive leg of a capacitor, and then the negative leg of the capacitor connects to here. And we can verify from here to ground. Ah, I slipped. I slipped. I slipped. I slipped. Help, help. Call mom. It's real bad. Okay, there, that is ground. So this is definitely a ground plane. This is definitely a ground plane. R5 and the BJT. This one? Oh no, this one. This one goes up to other stuff. It actually goes down and around to all of the LEDs. So this actually gives all the LEDs positive power. And for some reason, it goes down and around. I don't understand why. It's like the dumbest thing. And then there's all this garbage left over from, I guess, other designs like this. So yeah. That is definitely what's here. It would make more sense if Y2 were an NPN. Let's do the schematic symbol cookbook. One sec. Hey, what is this? That's circuit board. I guess I gotta close this. I really don't want to close this because this is the only, they're not, Osh Park didn't send me an email, so. Panel year boards are assigned to have been sent to the fab. I guess they're still fabbing. I hope they don't have to work during Christmas. Okay, so yeah, going to PNP versus NPN. Let's just look up the SMD code book. SMD code book. We could also do a diode test on the transistor to see what it is, but we've got a Y2. And it's on an SOT23, but it's not a Zener diode. This is a terrible website. Don't go to that website. Sphere.bc.ca. Well, there's the PDF. This one's going to have a lot of stuff, but it's a little bit outdated. Control F, Y2. Should have about 1 billion Y2s, and unfortunately you can't really search it by the column, can you? 9A, 9A, blah, 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 blah. A, B, C, D, E, F, G, H, I, J, K, W, X, Y. All the way up to the top. Only 2 Y2s, huh? Gallium arsenic FET, field effect transistor. I don't think that's it. MW6, like I said, outdated information. SOT23, Zener diode. So Y2, SOT23. I'm like, I thought I heard my dog, but my dog isn't here. She's not here. Yeah, that is actually, that's a hardcore RF transistor. What are they using? What's doing 3 gigahertz these days? What's in that spectrum? I've seen no references to NPN, even in passing. It has to be PNP, but that begs the question, what the hell is going on here? Because this circuit, something needs to discharge this. Where's that positive power going in order to keep this thing in bias? It's not ghosts. You fuck. You absolute fuck. What are do? What are do? I mean, it could just be an NPN transistor, in which case it makes perfect sense. How do we know? Yeah, there could be something under the cap. Well, there isn't. Let's check PNP. So if it's PNP, the multimeter. Thank you guys for the follows. God damn it! Hold on. Transistor as diodes. We can use the diode tester to determine whether or not this is a transistor. And so the location of the diodes as we test it, depending on how it's blocked, will tell us whether or not we are a PNP or an NPN. So if we are a PNP, like we expect, I should be able to put the positive lead on one end, and then on the base, the center part of the transistor, I should be able to put the other. Let's find out. It's wrong view. Wrong, nope. Okay. So if I go into diode mode, I'm actually going into the forbidden mode, and I get it into diode mode by pressing the button. I can go to the leads here, and I can go from base. That's not the one. That's not what we're testing. We're testing this one. Go from base to collector. So my negative lead is on the base, and my positive lead is on the collector. And I get a voltage level. 0.7. 0.7 volts, like a typical diode. If I go over here, 0.7 volts, like a typical diode. If I mix it up a little bit and I try to do it backwards, I get bupkis. It's a PNP. There's no doubt. There's no doubt in my mind that we have a PNP to, wait a minute. NPN would be positive in the middle. Negative would be, hold on, negative on the base, negative on the base, negative on the base, positive over here. Negative on the base, positive. Yeah, that is PNP. Yeah, that song has been in my head. I've made references to that several times, and it's unavoidable. Okay, what the hell? We have positive power here. We have a bias, we have a current limiter, we have a trigger. positive is going to a 220 off that goes here. The only thing that I could think is if this is not connected, because like this is the totally passive green LED. Green LED is not involved with the EMF part of the circuit at all. Ah, there's fucking beep mode. Ah. So yeah, it is connected to ground. So there are no tricks here. Why is the green LED constantly active? 220 ohm to ground. So what we're doing is we're switching positive through here down to there. It is basically just a power light, and we've made that confirmation by virtue of the circuit around it. But unfortunately, we're running into some problems here because it's connected like this, right? It's connected like this. This would have to go to negative in order for it to activate the transistor. That's true. 4.7 kilo ohms on 9 volts through charging a 220 UF cap could be rapidly discharging. This could be rapidly hitting that, and so the LED is just not as bright as it could be. If I turn it on, it did a little thing there. Looks like it doesn't flicker beyond that. Charge, blink, and then it's back. It's sort of you can see it charge back up. It doesn't look, I mean, from looking at it, obviously, you might not be able to see it flickering. Huh, weird. I don't know why that's... Okay, well, anyway, we can move on, because we know it should work. I do have an oscilloscope, but we're just not... I don't really want to hook it up right... Ah, fine, fuck it. Fuck it! So let's get the oscilloscope. Let's just fucking just move over here. Let's just do this. And then just do a little focus. Oops, it's the wrong focus. Might have to do 2 streams on this one. Just the reverse engineering of it. Because I am really curious about how this thing works. I really want to figure this out. We're going to be back on Tuesday, so... Ah! Okay, just bend one of the LEDs while I'm at it. Let's just quickly look at what's going on the base of the transistor. So I'll just hook this thing up to negative. I guess I'll just press it against negative. That should be easy enough. And then I'll probe in on the base of the transistor, and we'll see what that looks like over here. Yeah, I actually don't need to do anything to my stream schedule on the holidays. I do Tuesday, Wednesday, or Tuesday, Thursday, Friday, because on Tuesday we always find out that I need to order 500 things to make the project work. And then Thursday, Friday, and then I've been doing Saturdays, usually, or typically I would like to have Saturdays be gaming streams, but that's not always the case. Yeah, and that's the schedule. So we're not doing a Saturday because of the holidays. It is positive. It is very, very positive. What about you? There's like a little tiny fluctuation in it, but it is a positive voltage level. How can that be? How the fuck? Maybe I got the pins mixed up or something? There's like noise on the LED line. It's probably caused by my lighting. And then this one's the base. It's like solid. It's super solid. I've got 2, 4, 6. Yeah. 8, 9. It's 9 volts directly on that pin. What the fuck? It's not a Zener diode. There's all kinds of other electronics connected to it. Whoa. That's our source. Or no, that's yeah, this should be just positive 9 volts, yeah. This should be the base. And the base should have stuff going on, but it doesn't. It's super solid. So the emitter has just a little bit of dirtiness in it every now and then. Just a little bit of a blip. No, it's just negative because there's nothing in there. What the fuck? It has to be an NPN. But we diode tested it, and it's definitely a PNP. What is going on? Wait a minute, what is going on here? Did they flip the... that doesn't make any sense. That doesn't make any sense. No, it's not AC coupling. Everything we see here is doing just fine. You just said AC coupling because you wanted to sound smart. You just wanted to sound smart. You just wanted to get in on the conversation. You just mention another mode for the probing. You'd have to be brain dead in order to have activated. Let's see. Nice schematic, not an EE. Try to keep it simple, you know? I mean, I don't know what else I can look up. This circuit is functioning in exactly the way I would expect a PNP transistor to do it. Or sorry, an NPN transistor to function in this role. This would be putting an NPN in place of a PNP. This would function... No. Oh, I'm dumb. No, wait, no, I'm not dumb. I'm not dumb. I'm not dumb. Wait a minute. No. Capacitor starts as a short. And so that would bias that to positive. 4.7K is a weak pull-up. So it starts as a short and biases it negative, which means more current can come in from the base, and that charges the capacitor more, and then it ends up positive. But a PNP is active negative. Don't think so. Double check. What did I mess up? And we did the diode test and we determined that it was PNP. No, that's a PNP. That's what I got right here. PNP is active negative. Got to double check it sometimes, but that's what we have. This is what we have. This is exactly what we have. And yet, we have a positive bias on the end of the PNP, and the LED is somehow lighting up. So I think I've messed up part of my drawing. That's not my drawing. That's not my drawing at all. The PNP above that is a small a small signal transistor configuration. You don't just have to use transistors as switches. You can use them as other types of things. Like you can use it as a small signal amplifier or whatever. But you get a small current from here to here, and it amplifies it as a large current from here to here. This is backwards. Okay, double check. PNP transistor pinout. Double check that. Dear God, do I not want to have to deal with these fucking things. These motherfuckers right here are something that you would run into if you're doing like breadboarding and you know, putting together your initial circuits in electronics. And I think they're designed exactly to confuse you, because you don't know if they are showing you a view through the top or from the bottom of the board, and they will do both. They will do both. Seems stupid to have this transistor circuit just to light the LED in the first place. Yes, but I don't know. They're just confusing us. I mean, I've got the same thing on Burn the Subs. We're gonna have that, but the point of it is that if it goes out of spec, I guess you can make it just barely switch the transistor, so that if it goes out of spec, then it will stop switching the transistor. It's okay. Hold on. Let's double check. Got to put the package in there. That is very useful and very large. Thank you. B, C, E. That is an NPN. Jesus Christ. I love it when you search one and you get the other. It makes it so nice. And Which one is this? Marking diagram, SOT23. Is it a PNP or an NP? Oh my god, I'm gonna fucking... Visit. Zoom way the fuck in. My eyes are old man eyes. No, I got it right. Emitter, collector, base. And then in that scheme, the collector is hooked up. No, this definitely, we ohmed it out. It's PNP. You know, we did the diode test. It's definitely PNP, you know. We did the diode test, but the circuit behavior is like wrong. I don't get it. I don't actually get it. Do you make logical charts outside of EE? I don't know what you mean, actually. Maybe, I don't know. We've gone through all the steps to vet this out. I don't understand why it works. What else is connected to the positive lead of the LED? Maybe that's something that's going on. Well, no, that doesn't make any fucking sense. Positive lead of the LED, I don't think it's... Okay, I'm starting to get angry. We've got a weird mystery on our hands, gang. So the flat spot of the LED indicating negative, and the toilet bowl indicating negative, going to a resistor to ground. That is very clear. Positive lead, not going anywhere else. Going straight to the transistors. Emitter, collector, whatever, that branch. Double check, that branch is the one without the thing. Yep. Excuse me. Then base goes to a 3.3K. That's 330 with 10 after it. So 3300, 3.3K. Other end of that 3.3K has a 4.7 kilo ohm resistor that takes it to the positive power trace that sits at 9 volts. That 9 volts also goes to the whatever lead of the transistor, what is responsible for its switching. So how in fucking Ghost Town, how in the name of Ghost Town, this capacitor sitting here, this branch of the circuit right here and on the other side are sitting at 9 volts, thus biasing this thing against operation. I'm speechless. I do not know how this is working. Because, like, this should be super simple. We verified all the levels of everything too. Super weird. I'm a little creeped out by it. Why are that work? I mean, maybe this is just the Zener diode. That would make this part really confusing. Well, if this is positive power and this is Q, it's labeled Q, so it's a transistor. Otherwise, it would be Z. Bypass to cause flickering. Sure, but first of all, it barely flickers. It's just literally just like a power LED, which is what I expected out of something that's trying to be a little deceptive. But like that Q7 circuit is just there. It's basically just a light. Is 9 volts too much for the transistor? That doesn't make any sense. I bet you if I remove that 3.3, this thing doesn't light up. That means we're going to be charging that through a 4.7. Let's try it. No, I don't want to alter the circuit yet. If I bypass the capacitor to discharge it, ground, will the light turn off? That's what we would expect out of an NPN. Actually, all of the LEDs were turning on when I was doing that. Weird. Because that doesn't branch off to anywhere. There's nowhere else that it goes. Oh, it crosses right by the coil. That makes sense then. Does it? All of the LEDs were turning on because we were putting an opposing magnetic field across it. Because okay, so what I would expect is, I mean, that has to be an NPN transistor, but we did the diode test, and the diode test said it was PNP. Why must you forsake me, Father? Father, I've done the test. Why do you cast me away? This is what we had. We did this. We definitely did the negative lead on the base, and then both of these tested as a diode. This tested as a PNP. So why then does the LED light up? Doesn't make any goddamn sense to me. Chat, I've lost my mind. Completely lost it. If I put the positive lead here, I get nothing on the two ends. Evidenced by this. So yeah, I guess we found out our first ghost. I did test it in circuit, yes. So it's possible that I would be reading other diodes. But, I mean, the results are pretty clear. I'll do it again. Sanity check. Sanity check. Circuit off. Power down. Power it down. Power the circuit down. Let's go back into diode mode. Let's just check. Positive lead definitely goes to the positive lead on the multimeter. Caps are probably not discharged yet. Negative lead confirmed for base. My sanity meter has gone haywire. I mean, in all, oh wait, wrong one. In all likelihood, this is just me being stupid, because it should be an NPN transistor. The way it's behaving and everything evidences that. A little beep, and I got a 0.7 volt drop going from positive on this lead to negative here. We get the LED turning on, and we get a 1.8 volt drop. So that's two diodes that I've tested there, and they've gone perfect. Right there, just like that. 0.7 volt drop. So I take it over here to the collector, or emitter, I forget which one, and that one's got a 0.7 volt drop. So yeah, there's your sanity check. Reverse the leads. Now I've got positive on the base, negative on the collector, nothing. Positive on the base, negative on the collector. Nothing. Double check with the internet. So it was negative on the base, and then those two tested as 0.7 volt diodes. That's as simple as it gets. Simple as. But I don't. Maybe this transistor like flops the leads, or that doesn't make any sense. Doesn't make any sense, right? Where's the base? Drop in a base. So that would be negative lead right there. Positive lead right there. 0.7 volt drop. Look at the web page. Negative lead right here. Positive lead, either of the other legs. That's a PNP. It's PNP. Why does the diode light up? There's something weird that I don't understand. Is it too much for the transistor? No, the transistor should probably be able to handle like tons of voltage. Why am I buzzing? Hold on, I'm buzzing. My dog misses me, or at least that's what my mother says. Oh my goodness. I am not going to show you this picture because my niece is in it, but it is a very, very, very cute picture. Bryn has adopted. My cousin has adopted Willow. Heartbreaking. and warming. Okay. My niece has co-opted my ownership of my corgi. I miss my corgi. Yeah, I'm confused. This is a rare time. We're looking at a transistor that should be in a switching mode, and looking at the voltages that are present on the legs of the transistor, it's not in a small signal mode. We don't have like I wouldn't expect it to sit at 9 volts if it was in some kind of a small signal mode, right? I mean, all things considered, big transistor, 47K is the value that we have, but it's not going to be V minus. It's going to V plus. So, I mean, maybe it's biasing it in the other direction. I mean, there's a 10 off there. We don't have a resistor across that. We don't have a resistor across there, right? No, we don't. Just this guy sitting out there, alone, rejected. I mean, there's that goes to positive power. We will have to clean up this circuit later, but that goes to positive, not negative, with the capacitor. Anything else on that line? I mean, yeah, no resistors. The Zener diodes on that line. That's after the 3.3K, and there's like a big coil over there. It does weird stuff. Trace between the two resistors, because they're connected to one another. Now the 4.7K is pulling up that branch of the circuit that's before the base of the transistor. Where does the voltage go to next? I don't know. I don't know what you mean. I don't know what you mean. This trace right here is positive power. We've confirmed that. So this branch over here, hold on, gotta get this. This branch right here goes to all the positive powers of all of the LEDs. And it looks like they're all biased to negative on these things. So we can actually just write down that part of the circuit quickly. You think a constant current source, but everything I know about PNP tells me that it should not be activated by that. All right, so the one on pin 1. Oops, pin 1. Pin number 1. 4.7K to the YL. Pin 1. Actually, there's none of that. It just goes direct. And then this, like that. And then this to 9 volt. That's what all of them do. So I'm just going to take that, cut and paste it. Hopefully it fits. Oh, I need to make it a little shorter, huh? Yeah, it's a little close. It's a little confusing, but I'll just keep it, because we will redraw this to make it a little clearer. Look at that. It's almost like I knew I needed to give it a little bit of space for the LED circuit. So this one is Y1. Pin 14. Wait, hold on, wait a minute. That's pin 14 is Y1. Whoopsie daisy. Pin 1 is down here. Which one is, nothing is, oh, pin 1 goes to G2. Okay, so it's G2 then Y1. So that's easy enough. That's easy enough. Correct my mistakes. Y1. So G2. Y1. I'm guessing it's going to be the red, or the Y2. Sorry, orange red, ORRD. What is Y1? OR and then RD. So what I can see right now is that this branch of the circuit is going to be biased in such a way as to be on the cusp of activating all of these LEDs at certain levels, right? Oh yeah, that might be an L. You're probably right. We'll make it an L. G1 is connected directly to the power supply in such a way as to really confuse the electrical engineer in the room, but I don't know, maybe that's just maybe I'm missing something with this, right? There's probably something I'm missing, because fundamentally, according to how this thing is built versus how it acts, it is acting as just like a power light. It might be a little bit more sensitive than a power light, but it seems like that 220 microfarad capacitor and the 4.7K resistor is a pretty common pairing in order to make your transistor fade in the LED. It just fades it in nice and easy, and it looks good. So anyway, we're biasing the comparators in such a way as to put a slightly altered positive voltage on your voltage divider on all of these. So we got a voltage divider going on between this 3.3 kilo ohm resistor and all of these various values of resistors going to each individual LED. So you can see 15K, 115K, 160K, 390K. So they're getting larger and larger and larger. And actually, this one's 160 by way of 115 by way of... So actually, wait a minute, that's going in the opposite direction. That's a little different. There might be some things that I messed up here, because the 390K is a significantly larger value. This, in order to get power all the way to here, you're going through all of these resistors. So this would be the lowest value. So what's going on there? Maybe I've got something mixed up. There's probably a little bit more circuit that I need to go through. That, or they're relying on positive and negative swings. But then what the hell is this thing doing? We're half bridge rectifying whatever RF signal we're getting in through this circuit. So whatever this is doing, it's got some kind of we'll have to figure out this part of the circuit a little later. But this part of the circuit is causing probably some kind of a weird thing to happen. We've got a lot more circuit stuff on this line and on this line here. But the coil is biasing it with RF, and then we have something that's comparing it with a very sort of tight margin in voltages, and that will cause the activation of the LEDs. So G2 would be the weakest, so I don't know why that's all the way up there. Oh, it is definitely an RF circuit. The coil, there's no ground plane around the coil. So the question is it legitimate? And it probably is. This part of the circuit is not. The first green LED is completely unrelated. The problem with that is that I don't know for certain. Most of what I see about that green LED is pointing towards it just being a power okay light. And the way it fades in is via the 4.7K and the 220 microfarad capacitor. That little fade in might make it look like it's expensive and nice, but that ain't the case. However, the rest of the operation of this thing is down to RF magic, and I would like to get into that. It is 6 o'clock. I'm hungry. So what I'm going to do is I'm going to just put this in stream, and I'll make a new folder. New folder. And I'm going to call it EMF Ghost. EMF Ghosts. Ah! So that'll be the folder we'll work out of for this one, and I'm just going to call this schematic boo.png. So that'll be what we'll work out of when we start this back up after the holiday on Tuesday. For those of you that celebrate, I guess Merry Christmas. For those of you that don't, have a nice weekend. I am going to end up driving 5+ hours. I just heard footsteps. I think I angered the ghosts. The ghosts are mad. I want to get to the bottom. I want to get to the bottom of the RF part of this circuit. That's the part that I'm most interested in. So we'll pick up where we left off. And, you know, I don't want to talk about this too much in the Discord. I know the stream projects section will have people who have ideas about things, but I don't want to I don't want you guys doing any homework on this because I want to bring us through it. I don't want to come back armed with the knowledge of exactly how this works. It's better to not know, because then we'll have fun figuring it out, and we'll figure out how we get that information. Because we got some weird stuff. We got some transistors that are sitting on coils. We've got Zener diodes that are participating, I guess. We've got half of an RF signal that could go positive and negative. Where can I find your Discord? I can give you the end command, and that will link to all of my social and or otherwise medias, except for Mastodon, which I have not figured out yet. I don't know how Mastodon works. I don't know how Mastodon works. I think you need to be a computer programmer in order to figure it out. I don't know, or maybe not. Anyway, I'm going to end. I'm going to be around tomorrow, and then I have a lot of driving to do on the holiday. I hope that we will be back on Tuesday, and I believe that will happen. And we'll work more on this thing. So you guys have fun. Call your mom. She misses you and all that stuff. I will catch you guys later. We're not going to raid anybody. Keep an eye out for Flatulent Gonad or Davies. They're always playing My Summer Car. And, you know, the usual suspects. You guys know where to go. I will see you guys